Hello, please. Hello, please. Twitch. Hello. Okay. YouTube. Okay. We are a go. How are comms? Is this seems like it? Maybe I have it turned up a bit too. It's just too loud for me. Okay. That doesn't seem okay. So my system volume does not seem to affect what stream hears. That's good to know. Good to know. Okay. Okay, so yesterday we did some things. We did some cool stuff. What did we do? We got some pre-generation of the terrain chunks going. And not actually generating the meshes, but we have the vertices and indices buffers out here. And that means that the nav mesh can be built even when there is no mesh or no collision, which is cool. And so we got that done, that system done, and then we started working on a PCG node. And what we were trying to do is recreate this right here, world hit ray query, passing it into the surface sampler. And I had copied the world hit ray query node in C++, and we were working on that a little bit. And I say a little bit, I think I spent probably like 3 hours just trying to make it work properly, and it was just, oh my god, way too complicated. For what I needed. And then ended stream, and I was like, you know what, I'm just gonna do it my own way, and I'm just gonna return this because like what we were trying to do with this node is like this node relies on these rely on collision, and we don't have collision turned on because we don't have a mesh generated. We just have data. That's all we have. And so I was trying to just use to do like a trace against my vertex and indices buffers, and it was not only very unperformant but very complicated, and it wasn't even working properly. And I was like, you know what, I'm just gonna do it my own way. I'm just gonna like iterate through the vertices, the triangles, and then just like I'll just return a point for every triangle. And I probably got that working in like 30 minutes. It was like so fast. So much easier to do it that way. And on top of that, I actually took it a step further, and now I implemented like a points per squared meter, very similar to how the surface sampler works. So I can go here and I can type in a points per square meter, and then I kind of like determine how many points should be spawned based off of the area of each triangle, handling some remainder and overflow. Very similar to how it doesn't seem to be the exact same density when I do it, but it's close enough that it'll work just fine. I don't think it's a legitimate points per square meter, but it kind of, you can think of it that way. But there's also I did a filter as well. This will be really nice. And let me pick one of these and show you guys what this can do. So 030, okay, let's grab that one, and we're gonna inspect this. Let's do axis tripod. Yeah. So what I've done here is I'm returning every vertex in this chunk, or every, like triangle. So I have all like the tubes, all the caves and stuff. And what this angle does, it does a dot product against the normal of each point. And I have all the points have the normals of the triangles that they come from. So I know which direction they're going, whether they're facing down, whether they're facing up, and then I can use this filter direction to cull the points properly. And so that's why we don't have any points on the ceilings here, because the first pass at this, I literally had fuzzy tunnels. It was quite silly looking, because there was grass all the way around on every triangle. Here are the triangles in question. There we go. There are the triangles in question. So rather than just one per triangle, which was, you can see how that would be a little uneven. And then I add a little bit of random jitter in there as well. But we also now we're taking into account the areas of the triangles too, so that's good. Little laggy. And this node actually runs, it's crazy. It actually runs quite well. Let me look at the profiling here. Okay, so we don't have profiling information. And what I want to do, let's actually change this to, so the dot product threshold will discard points whose dot product is less than this threshold. So 0 means perpendicular for a dot product, 1 means facing in the exact same direction, and -1 means the complete opposite direction. So I didn't mean to do that. So if we do -1 and redo this is going to be interesting because we may end up getting, I'm going to force region, we may end up getting points like trees spawned upside down and stuff. It'll be interesting though. But this chunk surface sampler, it's running in like 7 milliseconds, which is nice, really nice. And here are my points that show you the directions, so they should be aligned with the landscape, which is really nice. You can see how they flow with the landscape. Now, I'm curious. Oh, I also do a slope culling for the grass specifically, so that's why we're not seeing any grass here. But these points are being returned because they're less than perpendicular. But yeah, once this runs enough, yeah, you can see the oh yeah, I need to turn the let's do pcg.cache memory budget. Let's actually give it like 500 megabytes of memory budget, and then it'll run a bit faster because I think it's like garbage collecting every frame because there's no cache. So I may need to run that again. I promise it's working very well. But while that runs, oh, there we go. There are all our points. So now we have the points on the ceilings now that I changed the filtering. But I guess the slope filter is still probably taking care of the grass. But yeah, very, very, very nice to have that functionality, right? Because then I can also target the ceilings as well of the caves, and I can, you know, spawn like some stalactites and stuff like that. And another byproduct of this process is you can see there's no chunks here, but I have things spawned here. Why is that? Well, it's because I no longer need to rely on collision data anymore at all. So even though I don't have any meshes generated, I'm saving memory there, I can still spawn PCG on it, which is awesome. That's what we were going for. That's why we're here. Why we're here. So that's awesome. And then take a look at the nav mesh here, which is going to be pretty laggy. Oh dear. Oh yeah, it's super laggy. But I'm just trying to show the trees here, you know, they're affecting the nav mesh there, which is what we want as well. Perfect. Why did it look like that? That's crazy. Hang on, nav mesh. What is happening there? It's definitely because of PCG. Now I can't see a goddamn thing because of how laggy it is. Oh god, it's going all the way down. Interesting. Okay, so that's something we'll need to figure out. Let's turn that off for now. Turn that off for now. So yeah, this is working very nicely. Very, very, very nicely. Now, I'm curious. Why aren't my... Am I doing the meadow thing too? Yeah, we are. Wait, why am I not spawning meadow items down here? Oh, I think I still have the... Oh yeah, I have the not below 0 filter here. So that's why that's happening. That makes sense. So yeah, that's what I did last night, and that happened very fucking quickly, which is kind of crazy. And so now we're just going to pontificate upon some of the other PCG problems we have. Now, a couple of those. One of which is that this is going to take up an inordinate amount of memory if we keep everything spawned at all times. I don't need, you know, for instance, the grass data, right? There's no collision there. I only need the data for the things that have collision. So that's one step. God, and these are really dense forests, man. Holy shit. I do not need forests this dense, and we're only at 7 gigs of memory right now, which is pretty good. Pretty good. And we have a bunch of trees spawned underground. So that's problem number 2 that we'll need to solve. Now, that one might be a little bit more difficult. I have a plan as to how to solve not needing to keep in all of the points in memory. I think what I'm going to do is I have these hisms. What is a hism? A hism is a hierarchical instanced static mesh component. And that's what's handling the distance calling. When everything disappears and spawns back in, that's handled by the hism. And I can select which class to use in PCG, so I have my own class. And I believe I'm going to use this to handle calling itself and spawning itself, or rather spawning its points. I think I'll keep the hism itself spawned, but I will just not just distance call the rendering, but I think I will actually just delete all the points out of the instant static mesh and just have them serialized or something for things like grass, things that don't have collision. And so I think I'll just need to do a check there, and I might actually change my serialization system, because now that I'm not doing the runtime generated partitioned PCG solution, I think it's going to be a lot easier to just handle it myself. And as is the case with everything in Unreal Engine, like just handling it myself, specific for my use case, seems to be a lot fucking easier than trying to shoehorn the Unreal Engine built-in way into my use case, because I'm basically doing hard mode here. This looks so cool, like going in and out. Yeah, I need to call down the trees a little bit more, because the point density is actually a little higher. So yeah, that's what we're doing. That's what we're going to be doing today. Should I start with the easier one first? So let me think a little bit more about what I need to do is I need to be able to distinguish between what is underground and what is above ground. Now, traditionally, I think you do this with a raycast, which I do have some functions for doing a non-collision line trace and seeing if it collides with any triangle. But problem is I need to iterate over all the triangles, because I don't have it stored in a format that can be efficiently queried. Not some sort of, what do they call it, like a BVH format or some sort of space storage format. So I don't think, that wouldn't be my first choice. And that was what I was trying to do yesterday. And it was horribly unperformant. I was just trying to like essentially recreate what the ray hit query node did, but with my own data. And of course, yeah, that wasn't working out too hot. Another thing I need to do while it's in my mind, let me write some of this down. So where's my PCG thing? That's done. So voxel data is one answer to this problem. I already wrote that down. Turns out. So I need to, what do I need to do? I need to delete instances without collision when outside render, when outside player view distance. That's one step. Delete/load. And then another one is to solve, I need to do async processing. That's what I was going to say, async processing. Now there is a notion of, they call it like time slice processing within the PCG code, and I can follow what the surface sampler node is doing a little bit there, but I have a feeling that's going to be like annoyingly complicated. And it's running pretty okay now. Again, 8 milliseconds, so yeah, I don't want that running on the game thread, but it's okay for now, I think. I haven't profiled it, so maybe all of that 8 milliseconds isn't happening on the game thread. But maybe this will mean I do get a few more milliseconds on the processing of the points, but that means our game thread will be smoother. So we need to do async processing for points. Time slice, we'll call that. And the other one is determine point data. And this will go under there. Run terrain shaders if not already generated. So we're not using PCG for that at all, but we are kind of getting that out of the way first. Don't need to worry about that anymore. Read vertices from serialized voxels. Vertices tagged with what noise they get. Yeah. So this is we're gonna delete that because we kind of actually solved that. So we really just need to determine point data, underground, surface, etc. And I think we'll want to do material as well. And maybe the material can tell us whether or not we're underground or on the surface, although I wouldn't want to be constrained by that. So maybe we serialize and store some voxel data, which will mean taking up more memory. That will mean taking up some more memory. We're already storing the vertice and buffer data, which is what these are here, and I'm at LOD 3 right now. So it's about for the rendered things, for the rendered chunks that we can see in the distance here. For all these chunks, there are more rendered, or there are more generated. There's more data than this, but it's 13 megabytes for all these, to store the data for these, which is just vertex and index data. So not too bad. Not too bad. And there are, that's including the ones underground, but there are more generated. And so I'm also storing the data for all these invisible ones now too. So it's not going to be too bad. But I will need to, it is something we definitely need to keep checking in on as we do some of this. This is related, so I'm just kind of reorganizing here. Another thing I need to do is, like, you notice these straight lines. So the biomes right now just end on where the chunk ends. That's why we have this like one weird line of trees here. And what I'm going to change to do is actually make them end on the border splines, which is what the mountains are. So kind of just an aesthetic thing, so not super important right now. PCG still relies on collision. That's fixed now. Cross that off. PCG no longer relies on collision anymore, and that's wonderful. Yeah, so this is what we will need to do here. And we can also do some navigation optimization as well. Lock the nav component, or maybe even serialize it or something when there's nothing around. We'll see, because the nav mesh does end up taking up a lot of data when we render a lot of the world. Because I did do off stream, I spent like 20 minutes, like 20-30 minutes just like watching the world generate as far as it could go, and I got up to like 15 gigs of memory. And when everything was fully rendered, I only got like halfway to rendering the whole world, and that was 15 gigs of memory, and that was without PCG. So now I will save a considerable amount of memory by not rendering the meshes. So when I tried that again, I actually got farther. I generated more, and I think we were only at 10 gigs. So it's getting better. but the PCG stuff is going to take up some memory for sure. And we'll need to figure out what we can get rid of, what we can't. A lot of it's probably just the grass data. Like there's a lot of foliage and grass that we don't actually need, so it should get a lot better. But yeah, like the only idea I have right now for determining whether or not something's underground or on the surface is voxel data. I also mentioned doing some sort of math equation for a de facto line trace. Well, I say de facto because, again, we don't actually have collision, so we can't use any of the built-in line trace stuff. But at the end of the day, it's just math, right? I can determine if a line segment goes through a triangle. I have a function for that. And so how would I determine if something is underground or above ground? Now, I could, for every point, raycast upward, but I would have to iterate through every other triangle to determine that, to determine if it intersects with them. Unless I stored it in some efficient format, which is, again, more data. And that's essentially what the collision system does, right? Like, it stores the geometries in an efficient format such that you can query and not have to iterate over every point in these meshes. So if I'm going to do that, I might as well just render the damn chunk, right? I might as well just get the collision. So I'm going to try and avoid that if I can, because I've already seen how much memory that takes up and I can't handle that. So we're trying to see what we can get away with, essentially. I think storing voxel data is one such way. I think that'll take up less memory than... it'll take up less memory than, you know, collision data, mesh data, render data. I guess technically you could not have the render data, but still have the collision data. The dynamic mesh just takes up a lot of memory on its own. It stores a lot of information. The voxel data. Let me think about like what information I would want here. So at first I just want like underground / surface, which is essentially like what noise the point came from. And I can come up with that information two different ways. I can retroactively do it, because I do have like the individual noises. Like I have the height map data and I have the 3D noise, the underground noise. So I can query through that. And that is stored in a predictable format. Like I could efficiently query that. I wouldn't need to iterate through everything. It does get a little messy though. It does get a little messy. But I could retroactively do that. Say, come up with this data after the fact, after the generation, query the height map noise data and 3D noise data. It's because anything on the height map would be surface. Anything in the 3D noise would not, but it's like, would you consider what we're looking at here to be surface? Or, you know, because that's kind of the drawback there. Kind of the drawback there. I would like to have both pieces of information, and I think it's possible. I think it would be possible for me to do that. Again, the logic for that would be kind of a pain though, because the other idea here is pack this data as a part of the generation process. This would mean an additional extract pass for the shaders. So I'm essentially talking about whether or not I want to do this on the GPU or on the CPU here. That's the difference between these two options. I think both have some. This is easier. I think this one's easier. Doing it on the GPU during the generation process is easier, and it's overall faster. It will overall take less time, but when we look at a trace here, and we look at how much time these compute shaders take up on the render thread, it is what I would call non-negligible. Let's find one real quick. Wait, where was it? I thought there was one here somewhere. Wait, what am I looking at? Let's just look at marching. I think it would have to happen as a part of marching cubes, because I would want to just do it at the end. Marching cubes has both noises passed into it, so we might as well. I don't think this is probably a bad trace example. Okay, I know there are some shaders running here. Come on, give me a shader. I'm looking for a shader. I'm a shader boy, and I want to see a shader. Okay, let's try to find one again. Marching cubes. Okay, there it is. So here's our render frame right here. Game thread up here. So we only have one render frame to work with to do this with. Whereas if we do it on the CPU, we have multiple threads to do it. It can take however many frames it takes, because we don't really need that data instantly. We can do it in advance. And so we don't, and you can see the extract buffer passes are a good portion of this. And then some of it is uploading the buffers too. So it would increase this, right? But the reason I'm leaning towards this, even though it may increase some of our shader time, for marching cubes at least, and it's not like this is taking 7 milliseconds, our game frame, you know, it's taking longer than a game frame. Ignore this slate time, so, because that's all in editor stuff. So you can see we're most of the time very short game thread time. But I think we're going to need voxel data at some point anyway. Like, there's just no way, which it's really not even voxel data. It's really just more so vertex data. Because I don't have a standard voxel, like a bounds. Like, not everything fits into the same grid. So it's really just, I'm gonna call it voxel data from now on, but just know that it's not actually. But voxel to me means it's just a predefined unit of measurement, and then we're storing some data based on that grid location. But this is really just like vertex data. Oh, and the issue, oof, there's going to be a big issue with terrain deformation. You know, how do we maintain that voxel data? Right, because there's going to be new vertices. Do they just maintain, like, would I just like query, like when I do the terrain deformation, I would probably just say like, hey, whatever verts we're deforming, just copy their data into the newly created verts. Well, because eventually what I'm going to want to do is I'm going to want to have dirt underneath all this, right? I'm gonna want to have different materials within the ground, and so I'm gonna need some noise for that too. I'm gonna need some data there, which is why I feel like I need this voxel data, which, I mean, I guess marching cubes does produce a standard voxel size of data. Oh god, there we go. There's so with the marching cubes noise, it is for the most part a standard size. The height map, though, is not, and does not adhere to that. But I guess maybe as a part of my 3D noise generation, I need to be doing... a little bit of that. I need to be coming up with the shit that's actually underground as well. So, yeah, I think we should just do it as a part of the generation process, because I think we're going to need to do. So, is today the day where we start doing voxel data? We're going to do some shader shenanigans today as well. I don't know, but I think one thing we can do, let's do this part right now, because this should be easier. And I guess the reason I'm dragging my feet on this a little bit is I know we're going to touch the serialization system again, which is something that I'm not entirely happy with how it's working. It's quite messy. And maybe having each hierarchical instance static mesh handle its own data sets will make it less messy. Because right now it's in a subsystem that kind of handles everything. And it's just super messy to like query that and stuff. I think I still will need a subsystem, but maybe it can kind of dispatch out to the different terrain chunkisms and stuff. Which I think sounds better. It sounds cleaner. I just really like looking at this. Like, this is so satisfying to me. Seeing all these points generated. Like, I was so, like, when this worked, and it just worked the first fucking time. It was just, I wish it was on stream because it would have been euphoric. Yeah, I wasn't doing any angle culling on the grass, so the entire tunnel was just fuzzy. And when I was working on the points per square meter part, like, I way overshot the number, and so it was just like a super laggy, fuzzy tunnel. It looked quite funny. So yeah, here are some things that I need to work on in related to PCG. So we've kind of pontificated upon the problems. And I just named my stream that for the alliteration. Pontificating upon PCG problems. Promptly. So I think now it's time to do things. I've yapped enough. I don't know why. The voxel data actually seems quite easier to me, but I'm not ready. I'm just not ready for that. We're not ready for that. Because then that's just going to involve me doing PCG graph design, some design work. And I want to get some more assets collected. And I didn't fucking realize one thing that pissed me off so much. I didn't realize that when you deleted, like, I don't know which folder it was, but I've always heard you can delete, like, the intermediate saved and binary folders from your project, your Unreal Engine project folder. Apparently that gets rid of all your collections. Like down here. And I had a bunch of assets and collections, and I'm really upset that those are gone now. They're probably sitting in my recycle bin somewhere, so I might look into that and see if I can find them. But yeah, I want to get some assets ready before I do some more PCG graph design, because I've gotten a lot of Humble Bundle stuff and, you know, free for the week assets that I want to start throwing in here. I'm gonna get some different biomes going, make it look prettier so we're not just staring at the same forest the whole time. I want to do like a really swampy zone. I think that'll be cool. And I want to do the underground stuff. Okay, so let's work on this HISM. Work on get rid of PCG ISMCs that do not affect the nav mesh when not rendered in order to free up. So I have those open here. This is my base for all of my spawners. And let me make sure that I copy those over correctly. No, they're all just regular instant static mesh components. Okay, so I'll need to change all those. That's kind of annoying. And maybe it's time for me to turn the environment item spawners back on. But that's the serialization system that I was talking about. So let's just get some code down here. So what we want is when the terrain chunk, which should be the owner of this, is so when the terrain chunk updates into the non-rendered view, we want to like clean up some of the PCG. And we do run PCG. I'm wondering, because we're going to run the whole graph when we do that. We run it whether or not the mesh is actually generated. No. And it would be nice because like there's almost like 3 different types of points generated from PCG. Points with collision, that's one classification. 2 is points without collision, but points that still matter to the world. These are interactable points without collision. Then 3 is like non-interactable points without collision. And that's grass, which is a lot of the data. So it would be nice to just be like, yeah, don't run the grass parts. I don't know how to like. And these are, it's an on, I switched it to on-demand generation, so I don't think they don't regenerate if you change a variable in the graph during runtime. But I think that's a little, that's maybe step 2. Step 1, we'll run the graph, we'll generate everything, but once that's done, handle PCG finish generating, we will want to make a call to our environment item spawner ISMC base. I think here is where we'd want to do it, because yeah, we do need the PCG to finish generating. And maybe I can override some methods in here to just make it not even add the things if it's out of view. So I need 2 methods. One is going to be void, we'll say cleanup PCG points. I don't know, it's almost like a simulation mode or something. I don't know if cleanup is the right, a little misleading. Maybe like a terrain chunk update or something. I mean, we already have a terrain chunk update chunk method. And it would be like a serialized points, right? We'll do that next though. Let's just, we'll stick with cleanup points. And we'll say render PCG points as well. So two different things. Render PCG points, cleanup PCG points. And I'll need to know what my collision settings are, right? Hit collision enabled. If equals what now? No collision? Yeah, so if we don't have collision, just like delete everything. Delete everything. what functions do I have for that? Instances, clear instances. That's probably what I want, right? Clear instances. That may be all I need to do. Oh, async building. Hang on. Can these async do things? Is Unreal Engine capable of having built-in async options that actually work? Concurrent change. It does seem to have some async possibility here. That's really nice. We'll have to take a look at that at some other point. Put a pin in that. Yeah, this may be all we need to do. We just need to clear instances. And then when we render, now this is an issue because I don't have the points in the HISM anymore. All I have is this descriptor index. There is a way to, I assume, pass custom data. Something, right? There's gotta be. Isn't there? Material. Oh, instance data packer. Yeah, this is yeah, we can pack by attribute, and then we can put we can put the attributes of the point data in the custom data of the ISMC. But I don't need that for each instance. I just need that for I need that for everything. I need that for I just need one. Just need one. Because the entire data set's going to be the same. So, is there a way to pass data to the HISM that's not per instance data? I mean, I suppose this is where my own node comes in, because that has that capability. It's a little complicated though, so if I don't need to do that, I'd rather not. Okay, so yeah, I think I will need to use my own node for this, and I knew we were going to get back to that. I'm just regretting how complicated this node is, and I'd like to not ever touch it again. Oh yeah, because essentially I want this data table. I want this data table. This has all the references to my environment items and what kind of resource types they represent and how they can be gathered and all that stuff. So I just need a row handle essentially for that data table. So let me go back into that node I wrote. In the environment item spawner, there we go. Yeah, that's gonna be huge. But welcome in everyone. Happy Sunday. Let me show off again real quick before we get started what I was able to accomplish after stream yesterday. So yesterday I was streaming trying to get like my own node working. My own I was going to be a copy of the world hit ray query and surface sampler combo, but without collision, because everything in PCG relies on collision. I don't want to have to render my dynamic meshes because and to get the collision data because they take up a lot of memory. But I do have the vertex and buffer indices, so I ended up rewriting everything that I spent 3 hours on yesterday into something that was way more simpler, and it worked way better. And this is the output of that. Like, check this out. Like, you can go underground and I have all the normals from all these triangles. I have some options for points per square meter. I have a dot product, like, normal angle threshold. That's why we don't have the grass spawned on the ceilings, even though all these points are returned, you know? And then that means, like, there are no chunks here. These chunks are not, there are terrain chunks, which is just an actor, but there's no mesh. Mesh is not actually here. There's no collision here. And we have, this is going to be pretty laggy, despite there being no collision, we still have PCG spawned on there, and we still have navigation spawned there as well. It's incredibly laggy because rendering the nav mesh is expensive, but it's there, I promise. And these trees are affecting it. Same with the rocks that are all spawned by PCG. So that's why we did that. So we can do that. We're saving memory. We're using only about 7 gigs of memory right now, and I can do better, which is what I'm working on right now. I'm working on a way to clear up all the PCG points, all the instances from the HISMs out of this. So 1, they're not rendered at all, and 2, I'm not keeping like there's so much grass here, and it doesn't affect the nav mesh, so I don't need it. I don't need it there. So we're going to save memory that way. So we really only need the things that have collision to be kept in memory. Everything else, it's going to be serialized. So what we're going to do is I need a way to understand what the data represents. I need a way to, well, I guess rendering the points here. I need to read the save data, right? Oh man, yeah, so I knew this was going to get into my serialization system. Procedural terrain system. Get some of these out of the way. Clean up a little bit. The procedural terrain subsystem. This is where I'm storing all the serialized PCG points. So now, whenever I want to render the points, I'll need to load them. And I guess it's only if, first of all, only if collision is not no collision. Well, really, it's block. Oof. Actually, I actually need to know if it blocks the nav mesh or not. It's a little more complicated. Get collision response to channel. What channel do I use for the nav mesh? So it's really just like, does it affect navigation? Can I just get that instead rather than collision? And ever, yeah, let's just do that. If it can affect collision, then we render things. Otherwise, or rather, if it can't affect collision or navigation, then we need to reload it. Otherwise, it's going to be in memory anyway. We'll change that here as well. If this doesn't ever affect navigation, we're going to clear it up. Clear it up. Okay. So that's going to be entry points. Now I need to remember how this subsystem was used. Each one of these is tagged with like a save slot name. Where does that get set at? That gets set in the spawner. Wait, that was the wrong one. No, it wasn't. That's what I'm looking for. Yeah, if we have one. Now, oof, this is going to be potentially get or create managed ISMC, source components. Yeah, so all this was written with the assumption that we were using runtime hierarchical partitioned PCG, which now we're not. So this may be broken. A lot of this may be broken. Man, I knew I was going to get into this, and I didn't want to. Okay, but let's just assume for now that the HISM has the save file that we're supposed to use. And if that's the case, we can get or load PCG save. Yeah, and we're doing save slot name, and then we have grid cell, which is now, grid cell is actually now going to be terrain chunk coordinates. And I have whether or not we should await. So we can kind of just launch in a background thread maybe. Let's using namespace UE tasks. Let's launch a background thread here. Okay, it can just be background normal. And what we want to do is, do we have the subsystem already? Let's maintain a reference to that so we don't have to get it every time. The object pointer. Okay, let's get like a begin play or something. Is there a begin play? Yeah. For a static mesh component. I mean, that's. I think that should be. And then we'll just get the reference to the subsystem here, the pointer. Okay, so we have that. Let's go back into our background thread, and what we're going to do is, what are we going to do? We're going to load PCG save, and we have the save slot name, and we should have the owner terrain chunk, which let's also get that. I would like to just maintain a reference to that. It will be important. Include that. uProperty object pointer to terrain chunk. This is going to be the owner, so we're going to pass. I'm just fat fingering everything. Terrain chunk, get own. So these should never be spawned on not a terrain chunk. So terrain chunk ward, and then we do want to await, because then we will be able to return the FPCG save container. What is it? FPCG point container. I think. Is that what that returns? PCG save container, that's what it is. PCG save container. So the PCG save container, I forget what data is on here. Oh yeah, so now I need to go through this and like basically respawn everything. But this should have the data. I just forget like what all this stuff is. Is this the best way to do it? Is this the best way to do it, or should I just rerun the graph? It's a good question, because rerunning the graph, I think, effectively would respawn everything. But what would it do for the things that are already spawned? Would there just be unnecessary overhead? Let's just rerun the graph. Just rerun the graph, actually. Here, put a pin in that. We're gonna do run PCG. Yeah, so whenever the mesh generates, it will just rerun PCG. Does this, if it's already generated, does it generate again? Oh my god, okay. Could generate. So it's not runtime generated anymore, it's not partitioned anymore. Yeah, I think it would just rerun. I'm not going to dig too much deeper in that because we'll just find out. We'll just find out. Yeah, so that's just going to rerun. So maybe we actually don't need to do anything. So actually, run PCG on create physics states. Run. Where else are we using this at? When the physics state is done creating, which is after the mesh is created, or after the mesh is rendered when we're not going to, or after the mesh is cleaned up. Wait, we are calling it. So and we're just running it for everything right now. Which means it's just going to be constantly adding the points that we don't want. Okay, so how do we fix that? I guess I kind of need to make a decision on whether or not I'm going to stay within the PCG world, like within the PCG framework with this information. Part of me wants to just use PCG to get the points, just to generate the points because it's nice to work with. Generate the points, spawn the things. I'll handle it from there. No need to rerun the graph because there are a lot of all these nodes in the graph. There is overhead to them, right? This does happen for the most part asynchronously, but it also takes up game thread time. So it's okay to run it once and then, you know, handle it from there. But it would just like I'm essentially going to have to kind of recreate what it does on the spawning side of things. If I want to save on some bandwidth, some cycles, CPU cycles, which kind of feels bad because it's like feels bad to just be doing the same thing that the system already does. But that would mean I could, you know, I guess there would be a way for me to write the graph in such a way where it's like, oh, I have the loaded data, skip all the in-between stuff, don't run the surface sampler again, right? There would be a way to build the graph because there are like branches and stuff. Like I can branch and I can create I think I might have a node for like I can make a node for like whether or not some data exists in a file. That's not too bad. And then I can branch on these execution paths. That's kind of there's a lot of overhead to creating the graph though. I feel like that's going to slow down the content iteration time if I do that. I guess the easy form of that is what? I can easiest form of that is like just don't run the parts that don't have collision. Yeah, and there is a PCG cache. And if I don't want to use that cache to save on memory, then it is going to rerun the stuff. Yeah, I think I have to re-implement what PCG is doing, unfortunately. A little bit. I think it'll be more simpler than the way they do it, because I'm just gonna need to what I'm going to need to do is I'm just going to need to respawn the points. And download it from the save data and stuff. Okay. So essentially, I don't want to. I think I'm leaning towards only ever generating the graph once. And then we'll just rely on serializing the points. How much data is that going to be, though? Oh, so many trade-offs here, man. So many trade-offs. Do I want to save storage space? Or CPU time? Game thread time? What would be easiest right now? I already have the serialization system built, but it's probably broken in its current state. And what I'm trying to do, I'm essentially just trying to get rid of the grass points when they're on chunks that aren't even rendered. It'd be nice if I could generate the PCG with like some tag or something. I guess I can get attributes from the owner that the graph is running on. So maybe I should just get this mesh rendered boolean. And if I get that, I can just like not run certain things. I guess I'm just wanting it to happen automatically. Like I don't want to have to make every graph that way and manually put the nodes down for every thing that doesn't have collision. I want it to happen automatically. But I guess if we're just going to handle rerunning the graphs, that's what it's going to need. Okay, let's see if that's the easiest part. That's going to be step one. I don't like it, but that's what we're going to do. Make that public, be mesh rendered. And there is a get actor property. Yeah, that's what I want. Get actor property. Self. Either the original PCG actor or the partition actor. It is the we will have the PCG actor. Property name. What do I put in here? You only extract properties that are compatible with metadata types. Forget what format this needs to be in, but be mesh rendered. And let's just do some print stringing here. String can I just manually, or I just like create a string? Cast a string. Is it make string? Make. Wait, didn't I put this in the other one? Just create attribute. Okay. And then you select the string type. Okay. String value, and this is going to be be mesh rendered. Comma space. That there. Can I add more? I guess I'll just have to do multiple appends. Put you there. And I can include Prefix with component. Yes. No. Is that going to give me the terrain chunk coordinate? I don't know. Maybe. Maybe. We'll see. Okay. Will this just go, or do I need to? I think this just goes, right? Because I'm pretty sure this one is running. Save. I need to rebuild because that's not a public property. So. Oh, let's make it blueprint readable as well. That might need to be. That might need to be the case. Maybe visible anywhere as well, just in case we need that. Okay, let's build that. We'll see if we can actually, because I know there's some wonkiness with like how you get properties from actors in PCG. You have to do it a certain way. Circular dependency, awesome. Awesome. Why? What did I do in here? What did I change that? Oh yeah, I included the procedural terrain subsystem. Okay. Okay. Okie dokie. Run to the bathroom while it's gone. BRB. Okay, give me 1 sec. Undeclared identifier. Okay. Yeah, I think we can just include it, right? Blah, blah, blah. Okay, now bathroom. Bro, the circular dependencies, what the frick? Happy now? Okay. We built that time. That's great news. Okay, let's see if that's... Let's see what happens now. So we should be getting a print statement here. When PCG runs. Let's see. And it should be like v mesh rendered. Is that the right? Let me look here. Appended a string to nothing, right? V mesh rendered. What does output target mean? Okay, so yeah, this wasn't getting hit at all. How do we? Go to that one for now. Oh, that's just in. This needs to go into print string. Oh, I see, I see. Let's just put that, we're just gonna put that there. Okay. Oh, there it is. Now it's showing up. Do we have... Oh, we have the terrain chunk. Nice, nice, nice. Is it just always ticking? What's happening? Or is PCG still generating? I think it's still generating. So far, they're all not rendered. Let's rerun this again, because now that it's working, let's get a clean slate here. Okay, we are getting some trues. Nice. Okay, so we can't get this data directly in the graph. So that helps. Okay, and I am seeing some falses. Okay, so we can use that. Confirmed. We have confirmed. Cast to Boolean. Do I need that? Oh, that's wrong one. Let's pause regen while we're working on it. Okay. Output attribute name. Just call it the same thing as well. And it says cannot convert input attribute none of type string into Boolean. And I can't specify the type here. Output actor reference, output attribute name, force object and struct extraction. Frozen. Hello, please. Okay, what's happening? Not responding. Oh, we are at 25 gigs of memory. Okay. Not good. Not good. Wait, why are we're at 30 gigs? Okay, hang on. Something's going wrong here. Rebuild. See, this is why I'm a little worried about relying on PCG. It's great. It is really nice iterating with it and coming up with what things should look like, where they should spawn and stuff like that. That's all so nice. But my God, does it just hog RAM? It just tries to just cache its little heart away. And memory is, I think, my limiting factor here for my game, so. Yeah. So let me try to figure this out. maybe... See, the shitty thing about this is I can't test this on like another level. But let's at least, let's go into here, do a much smaller radius. 50,000, let's just do, let's do like 30,000. 30,000 radius, num extra chunks to load. Let's just do one extra chunk. There we go. So now we can iterate on this maybe a little bit faster. Okay. Are you still throwing a fit? Grab you. Okay, you're not even in here, right? Because you're not a forest graph. Okay, so we need to have the forest chunks. We'll do these ones. Pick you. Okay, it did convert it properly. I don't know what it was complaining about before. Let me get my memory usage up over here just so I can see it at all times. Okay, we're at 5 gigs in Unreal Engine. That's not too bad. Not too bad. Okay, so we have the Boolean. So now let's branch on this. This should be output to B. And so I will want to... what am I doing here? Oh, yeah. Okay, so... Oh my god, I need to clean this up for sure. Yeah, let's just get rid of that altogether. Actually, let's just do that. Let's just pass through there. We'll go there. Can I named reroute? Nice. Okay, let's name this B mesh rendered. Okay, so let's use that. And then I can just B mesh rendered. Nice. Okay, there we go. So now that's a little cleaner, and I can use that elsewhere on the graph without having to get into noodle hell. And if we're rendered, we are going to output to B, which is grass. Okay. You just go down there and hang out for now. There we go, and the grass disappeared. Hell yeah, that worked. Well, you didn't disappear. Oh, right, because you're in a different graph. You're in a different graph. You're not, though. Oh, and that does look like it properly disappeared now. Okay. Nice. Okay, that wasn't too bad, actually. I could, like, wrap this into my own little blueprint node to make it a little cleaner. And I don't need the print string, right? I can get rid of all of that and just stick with this right here. The branch. But maybe I can essentially do, like, and I wish they made it more accessible to create nodes in both C++ and Blueprint. You can do custom Blueprint nodes, but like the data format for these pins and stuff like that is just like so hard to work with, especially in Blueprints. Like there's just like all these different nested types, and some things are mutable, some things are immutable. So like sometimes if you want to mutate something, you just have to create a new set for it or something. And it just gets really confusing to work with, especially in Noodle Hell, I mean Blueprints. So I'm just going to copy this for now. Let's copy you. Let's throw you in. You can go away. I guess we can keep the not in water. B mesh rendered. Error? Why error? It's funny the way that's represented. If we're rendered, we output to B. Nice. Okay, so let's put you in there. And you go away. Looks messy. But we save. And all these should be getting cleaned up, right? Are we running? Are we doing the stuff and the things? All the forest stuff got cleaned up. Output to B, foliage, output to B. I don't need that grid size anymore. Maybe force regen. There we go. Okay, that's running a lot better now. Oh. And there went all the ones I'm supposed to keep around. Why the hell was that? Okay, give me this chunk. In here. B mesh rendered is true. Output to B. That is true. Foliage. Can't tell. It's so hard to know if this is like cache data or if the pin is actually output to A, output to B. Well, of course that has data on it, but and I guess technically it is outputting to B on this one. Oh, there's the stuff. Okay, let's just rerun. Let's get a clean slate. Okay. What we're looking for is we're looking for trees to be trees and rocks rendered on the invisible chunks, but no grass. It's working for the forest biome. That's good. It's good. Okay, yeah, it's working now. It's working. Yeah, there's my rocks. Okay. Yeah, I wonder if this is the kind of thing I should just build into the spawner. The thing is, I haven't overridden that yet. Like, that part is not... God, the slog I went through creating this node. Oof. Yeah, so I just like... I still let the because what I'm doing with this spawner node is I've extended the static mesh spawner, and I'm just like kind of intercepting the data and tagging it and doing my own RNG on it to pick what to spawn, and then I just like tag the data a little bit, add some attributes, and then let the spawner spawn things based on the attributes. So I would need to essentially not return the data. I would have to intercept the data and then just like I serialize it, but I don't send it to the underlying, which I think is prepared data internal. If I wanted this to happen automatically, and then I would just have to basically check if the descriptor, if the instance static mesh descriptor has navigation turned on or not. PCG managed ISM component for each managed resource. What are we doing here? What are we doing here? Mark is reused. This is all coming back to me. Like a bad dream. Output point data has attributes. Instance list data. I know this isn't what. Okay, select instances. Here's where the RNG would happen, or like where it picks the static mesh to spawn with based on what attribute the point has. Packed custom data, we don't care about that. Mesh instances. Yeah, that's just packing data that I'm not using, so I don't care about that. And I get, okay, it's in the execute internal. But we do still assign point data here. So I think I would need to do this before I call the prepare internal. Because what do I do with execute internal? I don't think I do much there. Yeah, I just check to make sure the metadata is good. Okay, so the context. I hated this because it runs so many times because it's async, and I'm like trying to save and load data, like serialize it and stuff in the middle of that process. So there's just like all these different conditions that I gotta check for. God, I'm so glad I left this comment here. Apply environment item metadata, serialized tag data. Thing is, I'm using the context to kind of ferry the data around. I guess I need a wrapper around this call right here. Because I don't want to remove that data from the data set entirely. I want to keep it around for me, for my purposes, but then I want to take it away from the underlying here. But at the same time, I don't want to fuck up like the context and stuff, so I use it later down here. So that's kind of difficult. Ugh, that's kind of picky. Gonna be kind of picky. But it is possible. And I could just restore the context afterwards as well. Okay, let's try to run around a little bit and see if like the stuff spawns and everything properly. Now what's happening on the game thread right now? We're sitting at like 90 FPS, so I just want to see where that's coming from. Game thread idle time. Okay, we're just like deferred rendering everything. I feel like that's not usually the case. Okay, we'll ignore that for now. Yeah, so are we rendering more out here now? Did we unrender anything? I don't think so. I should turn on the renderer boxes again so I can see which chunks are like starting. Yeah, okay, so I think we generated another ring. Okay, did we clean up? Interesting. Those are supposed to... Okay, I guess that's fine because those are still within render distance. Now these ones are supposed to be cleaned up. Okay, so it's not cleaning up. when I rerun the graph, it doesn't delete these. So I do need to like manually do that, I guess. That part needs to manually happen. Yeah, the draw distance on the trees is closer than the terrain chunks. I'm supposed to have grass here. Okay, so I think it's relying on caches here. And when I rerun the graph, it just uses the cache data. Which is sad to see. Okay. What are we doing about this? Okay, so this not gonna work as easy as I thought it was going to, so that makes me just want to do it my own way. Yeah. And maybe if I used my own node, then it would work a little bit better. Okay. Because my node doesn't rely on the PCG cache, it relies on my own serialized cache. And if I'm always telling it what data to run with, then that kind of just handles itself. And it'll rerun the graph. But yeah, but then at that point, like, what's the point of rerunning the graph, right? Just to get into this node again? I might as well just manage the data myself, the point data. Am I just gonna do that now? Am I just gonna do that now? What is my cache? PCG.cache. Okay, so there's no cache budget. What is cache enabled set to? Okay, can I set that to false and try this again? Give me some new chunks rendered here. No, it still doesn't seem to want to respawn those. Yeah, and figuring out why and what kind of make those spawn would just involve me digging through the PCG framework internals, which is just not... That's not the vibes right now. Not how I want to spend my Sunday. Rocks. That's crazy, like it just like explodes into view. Okay, So yeah, I guess I do want to do my own thing here. So that means I'm going to reconnect my nodes and we're going to see what fucking happens, I suppose. We're going to see where it breaks. Okay. Let's stop that. Reconnect all these. Okay, and this, getting rid of that just entirely. Okay, I think that's good. We're not even doing that. Okay, tree, blah, 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 blah. Okay. I only have this set up for the forest. I never ended up doing this for the plain, the meadows. I mean, I don't really have any resources there, so maybe we just leave that. Maybe just leave that. Oh yeah, we're doing this world hit rate rate projection for hemp. Yeah, so none of that's going to spawn, which are the resources in this biome. Okay, we'll just, I guess we're just going to keep testing with, we'll just do only the forest graph. So I guess let's just see what happens here. We'll see if it just breaks or what. We do have things spawned. There we go. I knew it was going to happen eventually. Add PCG save to cache. Okay. Any log? Name, illegal name. Okay, so this save container is just an invalid pointer. F string. Oh, because we're getting the save slot name from it, yeah. We have mesh instance lists. Yeah, this just became invalid. So let's follow the stack trace. PCG save internal. Call this from save and cache PCG save, which I imagine is probably what we did. Which comes from serializing the tagged data. Do I have any information on like what was trying to do this? What was trying to do this save? PCG save infos. We have a ton in here. We have terrain chunks and everything. So all those saves look good. Okay, Why would this have been the case? Do I have a save container here? What was my last log? Okay, saving grass. Do I have any grass points already? Yeah, I do. Okay, so it's not just, God, there's so many points to realize there. So last thing we were saving is a bunch of grass points. Whew. We call save container save. Which I've apparently put the debug name as load on there. I imagine it did get saved, because like what, I'm gonna guess it's for x -1, y 3. Okay, so it didn't actually finish saving properly. At least it didn't add its name, which I guess is that's where it failed, right? Yeah. Okay, yeah, so we just had like some save container just going invalid or something, and I don't know why. Because don't I like... Isn't this just like a hard ref somewhere? Or is this pointer just like a dangling pointer? Is it this case? Serialized tag data. Save and cache PCG save. Save container. Save internal. I mean, I do put it in currently saving slots, but that only stores the save name. That doesn't actually store the pointer. Okay, so maybe I have some pointers getting garbage collected or something here. And I do save container save. I do have save container hard refs. But I hadn't added it until this point, until before this. Or I hadn't added it before this. This is all on load. Get our load. Yeah, I think I need to add this to the... to this hard refs. Come on, Ryder. You just froze on me right when I was about to type stuff. Okay. If currently saving slots doesn't contain it, I suppose that's when we'll add it. Okay, let's see if that makes things better. And then I think we usually do this like after it's done saving. Which it would already be. Okay. Okay, let's run it, see what happens. Getting a lot of frame hitches. Yeah, very, very framey. Now, the thing is, are we loading? Let me look at this. Are we loading or are we overriding every time? We are overriding every time. So we're saving every time. Does this look like the... I think this is about the radius that we would want. Yeah, this looks right. Okay, I want to run again. And let's do a race here. So we can see what where the hitches are coming from. There are a lot of them. Okay, done loading. Let's look at it. Yeah, we've got some big spikes here. Oh, we're just doing... Oh, it's a the environment item spawner prepare data internal. Yeah, okay. Do I have all of my... Do I have all of my serialization methods tagged? We just kind of end at prepare data internal. Get actor of class. Yeah, they're all this node, just like taking way too much time. DX Diag. Love that name. Welcome in. Thank you for the follow. We're just trying to do some runtime PCG stuff. We're serializing points so that we don't have to rerun the graphs every time the world loads, because it's a fully procedural world. You know, we don't have collision, so we're just kind of getting PCG to work with the way that we want it to. And yeah, I wrote this. I wrote my own PCG node that does the serialization for me, but it is taking quite some time. Okay, so I do have my own profiler scope here. I should probably... Let's put that on some of these other ones as well. So I can figure out where these hitches are coming from a little better. My environment item metadata. I want all of these functions profiled. Then there was serialized tag points as well. Might as well do that one. Why not? Serialized tag data. Why not? Okay. Save and cache PCG save, save internal. I mean, those are pretty minor. And they go on other threads anyway, so it's not like I'd be able to capture the whole effect of that function. This one, that one's good to profile for sure. Surprised that this is happening on the game thread. Anything else I want to profile here? Fix up metadata. Yeah, that one's fine. That should be good. So let's just run live coding there, and we're going to retrace when that all finishes. Let's clear up some of our old traces as well. Yeah, that's a lot. Okay, that loaded, got that going. Okay, let's load in again. Yeah, there's the hitching. There's the hitching. Come on, finish up. I mean, I suppose we have enough. We have enough examples to go off of. These ones are probably the same thing, right? Yeah, pretty much. Pretty much. Apply environment item metadata. That is the culprit. What am I doing in here? That's so bad. Okay, so this is the RNG. Okay, I feel like this wasn't happening before when I first built this node, which was a while ago. Yeah, this is where I'm randomly picking which mesh to spawn out of the set. And I do remember at one point thinking that the way I was doing the RNG was very performance intensive, because I was just like generating a number and be like, hey, if this is a hit, generate it, if not, keep going up until a certain number. And then that was like not very performant. I'm forgetting if I fixed that or not. Oh, while running total threshold is less than initial spawn threshold and points is not empty. I'll have to remember how I was doing this RNG. Random pick spawn count. Let me see here. Random mesh index less than number. Just meaning if it's a valid index, I suppose. Well, we're already using it. Already using it, okay. Random pick spawn count. Mesh index to spawn count. That's just a map of the mesh index to how many I should spawn. So we're incrementing how many we've spawned there in that map. It's just like kind of like a running total for how many to spawn. Running total threshold, and we're just, I guess we're gonna check the threshold each time too. Yeah, well that's in the while, so that makes sense. Spawn point index, point. Mesh. Yeah, and then we set the attribute with the mesh. That's all we're doing there, basically. Spawn point index, range between points. And points is a copy. Yeah. And then we're just removing that from the applicable points. Okay, so I don't think this is doing anything. I guess maybe this random weighted part is maybe a bit inefficient. Random weighted pick. Yeah, so I'm iterating over... And I came up with the cumulative weights. Okay. Yeah, I get what I'm doing here. Do I need to do something like this? I suppose the other way to do this is to just have an array of integers where the integer is the index of the mesh to spawn, and you just add into that array based on the weights, and then that way you don't have to iterate over it, because you just like generate a random number and then the weight is baked into that array, because the things that are weighted higher just have more elements in the array. So I could do that. I don't know how much that helps. Like, this seems like, I think the most I have for meshes to pick here would be like 4. But I guess if it's doing at max 4 here for every point, then that can become a lot. Yeah, maybe I can change that a little bit and see what happens. Animated, yeah, so cumulative weights. Let's just like, let's call this instead weighted mesh indices. It's gonna be an int32. And we have item.weight. So I do need to get the total weight first, right? And then I can determine how many I need to spawn. Yeah, let's just get the total weight first, because then we can do another loop. Total weight, and so the number would be like probably always round up too, because in case it's like a number less than 1, we always want at least 1 in there. But I guess the number in this weighted mesh indices would be like, yeah, it's total weight divided by current item weight. Is that, am I understanding that right? So let's say we have an array, paint time. So we have an array. Here's like the weights. Let's say we have 1, 1, 1, 2. So we have one thing that should be twice as likely as anything else. So total weight would be 3, it would be 5. Total equals 5. E equals 5. And so 1 divided by 5 is 0.2. 2 divided by 5 is 0.4. So does that mean it takes up 20% of the array, and this should take up 40% of the array? 20, 40, 60, 80, 40, 60, 81. I think that's right. And then I take this number and then I multiply it against that number. 4 times 5. Right? Should take a, yeah, why is this tripping me up so much? 2.4. So it would make sense that this should all add up to 1. What's 5 times 0.4? 2. 5 times point. I'm just getting the number. So wait, what's the logic here? I know there's a way to do this. I know there's like a pretty straightforward, easy way to do this. It's just failing me right now. If I want like a cumulative weighted thing, what's the logic? Total equals 5. I mean, am I just adding the number? Like, it's a float. The weight is a float. So like, this one maybe is straightforward. What is the weight? 1 relative to the total mesh weights. What was I doing here? Cumulative weights. An array of float. Alright, AI. Save me. How do I add into cumulative weights such that the or how do I add into weighted mesh entities such that the number of indices of each one is properly weighted? Alright, Gemini, save me. Save me from my own incompetence. Oh my god, it puts so many comments in the code. It's weight times scale factor. Okay, is that what it, and what is scale factor? What's scale factor? 100? Oh, I see. Larger array but better representation of the small weights. Yeah, I don't need something that big. Okay, yeah, we still have the total weight, weighted mesh indices. Okay, let's copy that in. Yeah, we can do the reserve. That's fine. Okay. Scale factor, 100 is too much. I don't want an array that big. Maybe just 10. That seems like a lot, though. What if I just did 1? Let's just do 10. We'll see how that goes. Weight times scale factor. But isn't there, I think there's a smarter way to do this, right? Where I don't need a scale factor, and I can just determine the number that should be in there based off the weight. Can't you just determine the number that I'll say the count that should be in, what are we naming it? What are we naming it? Weighted mesh indices. Based off of the weights rather than needing a scale. Thinking. We're thinking. Oh boy. Oh boy. You're right to question if the scale factor is strictly necessary. My apologies. Dude, he literally is blaming my code. Gemini is blaming my code for... He's like, I'm sorry, I gave you that option because I was focused on interpreting your original code structure, populating an array based on weights, rather than stepping back to the fundamental goal of performing a weighted selection. And it italicized that. Kind of sassy, I'll be honest with you. You cannot directly create an array where the integer count of each index perfectly matches a floating point weight without some form of scaling and rounding, because you can't add index I exactly 5.7 times, for instance. Okay. Alright, what do you got for me then? Here's a much more common and direct way to perform a weighted average selection. Okay, sure. Cumulative weight selection. This method avoids creating the large array and directly picks an index based on the weights each time you need one. But that's going to iterate each time I need one. Edge cases. Requires iteration through part of the list each time you need an index. Yeah, that's what I have or had before. That's what I'm trying to get away from. Recalculate array method, previous answer is O of 1, yeah. Okay, I guess I'll just stick with that then, and yeah, we'll just try it out and see if it's more performant. Yeah, scale factor 10. That way we get one decimal place to work with, right? I think that's all we need. I think essentially that's what that is. Minus. Yeah. So random weight pick, and then we just random mesh index, then just equals this. Wait, random. Yeah, there we go. Okay, let's see if that gets better performance-wise. If not, I need to understand more about what. Oh, I didn't put the rest of it in there. Oops. Oops. Get rid of these comments. Goes out of here. Okay, run that again. Okay, stop. Let's clear the logs, start the trace again, and play. See how much hitching there is this time. Yeah, we're still getting. Yeah, we're definitely getting some. Okay, I'm wondering if the reason this wasn't happening before, because I was using the PCG like runtime hierarchical partition thingo mode. I wonder if that was like running it on the background thread kind of asynchronously automatically. Because I definitely did not have hitching this bad. It doesn't really seem like that. 337 milliseconds. Yeah, that's not what I would call good. What else is happening in here? Let's throw another one of these down here, and we're just gonna do. Call this the RNG section. We'll see how much of it is taken up of that part versus the other parts, which is just basically everything else. Because yeah, I may need to figure out a way for me to run this on the background thread myself then. I can probably just launch a background task, right? Got a couple samples here. Okay, that's good enough. Oh, that was recast. Frame sync time. Oh, that was like the player spawning. Yeah, it's entirely the RNG. Okay, I think maybe the problem is I'm getting misses here, actually. Let me think about this. Random picks, because we're only actually picking a point if random pick spawn count is less than max spawn count. let's do something like that. Let's actually remove from that list random pick spawn count greater than or equal to max spawn count, and that should be is that for this mesh? Yeah, it should be. Let's remove from the mesh index to spawn count. What am I doing here? So we come up with how many to spawn. Index to spawn count. No, we don't. We're keeping track of how many have spawned. I think I should be skipping. I should be removing. Yeah, but then my weighted mesh indices isn't the fucking... Why is this so complicated to do this efficiently? Yeah, so like once I've reached the threshold for something, I need to stop spawning it, and I need to, because what I'm doing here is I think I'm just picking random numbers until I have a threshold reached. And I can grab things that already have their individual threshold reached. And when I do that, I just skip it. And so I think I'm getting a lot of iteration that isn't necessary. So I think there's like everything has a relative threshold. Let me look at the node again to better understand this. What am I looking at? And so for, let's look at this, right? Initial spawn threshold is 0.4, which means out of all the points that are going into this node, 40% of them will be spawned upon. And each one of these has a weight. And a relative threshold. And the relative threshold, the max percent of the spawn points that can be taken up by this mesh. This can be used to prevent more commonly weighted but more useless meshes from taking up all the points. What was my intention here? I wrote this. Okay, I think I was worried about respawn. And so for like a set of points where you have like multiple... Yeah, this is like, yeah, this is just like a max limit. So it's like when things respawn, you know, you might pick a common one that has a limit on it. Yeah, this is a complicated RNG process, actually. I forgot I did it this way. Yeah, so that's the max spawn count here. Right? Total points times initial spawn threshold. That's like num total initial spawn points, which maybe let's save that as a variable. Num, I'll say total num initial spawned points equals that. It's a little bit more readable. Okay. Times the relative threshold. So that's max spawn count for this random mesh. Yeah, so there are going to be a lot of misses happening, and it would be nice to... Yeah, let's just remove from this list. And then if it doesn't exist in there... gonna get a lot of we're still gonna get misses because we're not. I need to remove it from the weighted mesh indices list, but then I'm gonna need to iterate through that and like remove them all potentially. There's no good way to I mean, I feel like that's still better than the alternative. I think Copilot understood the assignment here. Filter by predicate where mesh index is not equal to, yeah, this current one. So yeah, we kind of just clear the weighted mesh indices of that number. For performance. Yeah, I think that's better than what we had. Again, we're multiplying by 10 though. So there's even still some performance issues there, but at least it's not a order of magnitude time complexity higher, just based on RNG. Well, I think that's better. Okay, let's trace again. Run. Oh, there. Okay, we're still getting some hitches. Hitch, hitchy, hitch, hitch, hitch. Yeah, not much better. Not much better. I got like 100 milliseconds out of that, maybe, because it was like in the 300. Well, no, there's a one in the 300. So that didn't make it any better, did it? That didn't make it any better. Random mesh index. Weighted mesh indices. That would never be the case, right? Here, let me do an else here. I want to know when this happens. Would this still happen? Oh, that's never getting hit. Just getting hit? Okay, that does get hit. Okay. What does weighted mesh indices look like? There's like 70 in here. Okay. I mean, I'm sure there's an array slice that can be a bit faster, right? Is a slice faster? Or is that still O of 1? Or O of n, time complexity. Yeah, yeah, this is just kind of a complicated RNG process, isn't it? Yeah, there's not a great way to skin this cat, is there? The cat is throwing a fit no matter which way it's being skinned. Imagine that. I'm actually kind of surprised that this takes pretty much the equivalent amount of time. Because before I was just rolling the dice and being like, oh, if it's already one that's at its threshold, roll the dice again. Which to me would potentially make it take a lot longer than removing the indices from the pool. Environment object, what is this? Oh, we're also doing this. We are also getting from a data table. Find row. Get row map. It's getting it from a map. So that's an O of 1 time complexity, and that should be fine. Although we get row map and then we do find. Yeah, but it's a map, so we just call find on the map. Which here's dot find, okay. Yeah. Yeah. Okay, so that's fine. That shouldn't be a big deal. So we can get rid of that now. Let's take this down to 1. Because that, again, we're not going to get very good. Like, we're essentially stuck to integers here for our weights. But let's see how much that affects this. I mean, it was entirely RNG, so it should be, like, basically, it shouldn't affect it at all, really. So I'm expecting nothing. No difference here. So this just turned into me trying to optimize my RNG, I suppose. Yeah, there's the hitches, there's the hitches, there's the hitches. Yep. Okay, great. Good news, everyone. It's still laggy. Yeah, still exactly the same. As I suspected. Is there any better way to do this? Like, it's just because there's so many points for some of them. Like, I am positive that it's the grass's fault. I am positive. It's crazy that this is taking 300 milliseconds, though. That's insane. Right? That just seems like so long, even though there could be thousands of points, tens of thousands of points. Let's just I want to see how many iterations this does. We're going to trace again because I can see what logs happen at what time in the trace file. There's some. Okay, plenty of examples. Okay, I think I accidentally clicked it again. Is it this one? Let me see. And I can like go like right after, and we will scroll log view. And it's num RNG ITRs. So let's just type RNG in here. What? Excuse me? Okay, maybe I didn't capture that properly. Okay, generating. Hitchy. God damn it, I started it again. Okay. That one. Okay. So wait, RNG. Okay, now it's showing up in there. Okay. Scroll log to this view. Yeah, so we have 13,000 iterations happening here. 15,000 there for that one. 14,000. I mean, I still feel like that's a lot of time for 14,000 iterations. Like, how expensive is running RNG? Is it that expensive? Is it that expensive running that many times? I mean, I guess so. I don't know if I want to spend much more time on that, because I feel like I could just kick this off to a background thread. Maybe I can optimize that more in the future, but I think maybe background thread is going to be necessary here. And is maybe the answer as to why I wasn't noticing this before. Is because it was happening asynchronously. Is there something I need to check on the graph or something? I guess I'll have to write it myself. Okay, so we're getting off into the weeds here a little bit on little side quests like optimizing this, which maybe I don't want to do that anymore because we're supposed to be pontificating upon PCG problems. We're not doing that very promptly, are we? I mean, I can just like put a little flag for like, hey, this is running, don't do anything until it's done. But maybe we'll do that at a different time. Because I'm supposed to be solving the problem of deleting points for this guy right here. And so let's do like a, this is going to be like handle prepare data internal. Okay, and so the problem, what do we do with context here? Context. Are we updating this at all in here? Well, really what I want to do is like, I want to like take the input data out of here so that it doesn't spawn certain things, and then I want to put it back in there after it's done spawning. Put it back in the context, I guess, so it saves properly. When the terrain mesh is not rendered. Because it's all based off of current point data. Oh no, we do update the context here. Shit. Okay, so that's gonna be a little bit more complicated now. Oh boy. Okay. Yeah, just create that function. Okay, so handle prepare data internal. We're just gonna return that, but we need to do some things first. We need to go through the data in here, which is what's again? Point data. Initialize from data, point data, which is coming from spatial data, to point data, which is coming from inputs, which is PCG tag data at index 0. Okay, so we need to do a little bit of this. Inputs. Let's just return true. If there's no inputs, we can just return true. We don't care about anything. In tag data, find by predicate. In, that's fine. In tagged data. Oh, we have to iterate over this again. We have to iterate. Oh my god, this is gonna get so expensive. Dot data, and I need to like cast this to point data, right? Input spatial data to point data. So I think this is what we'll want. Okay, so I need it to be spatial data first. Okay, cast it to spatial data, then call 2-point data on it. Okay. Okay. And this returns point data. And tag data.data. There we go. Does it need to be const? Yeah, it does. Okay. And so then I need to like, oh boy. What am I doing here? I need to basically... Is there like a copy? No, it just always returns const. A const pointer to point data, but I guess it's point data dot get points. FPCG point data, right? Or FPCG point. Yeah? Yeah, okay. For PCG point endpoints, I need to get the attribute from this point, or rather I need to get the descriptor from this point. For the environment item that it's tagged, my environment item metadata, which is, where am I putting that? Settings, environment items. Yeah, so I need to know the index of the descriptor. No, they all have the same template descriptor. Okay, I can just get that. Oh, okay, so I don't need to iterate over this. Okay, this is going to be a lot better. This is going to be a lot better. Yeah, because they all spawn with the same settings. Wait, and so stuff around trees, what did I do here? Some of these should have collision on them and some of them shouldn't. They're all set to block all. Boulders. Small rock. Small rock. Small rock. Okay, did I... What happened to my ferns? Didn't I... I'm spawning ferns, right? I guess I ignored that. Let me run again. Good thing is it's not crashing anymore, so I think that hard ref fix for the garbage collected pointer worked out. Show me... Oh, I am missing a chunk right here. Oh, there it is. There it is. Okay. Okay, I'm not seeing any ferns spawned in the forest. Okay, so maybe I just got rid of those. Okay, but it's nice that every point set will have the same collision settings, or the same whether or not it affects navigation, which should relate to the collision settings. So I guess I need to spawn ferns in a separate node. Okay, that makes things a lot freaking easier, actually. So really what I need to do is context. I need to get the little thing to settings here. If settings, descriptor, isn't it on settings or is it on the context? Where's that at? It's on the settings. It's just probably not named what I think it's named. Template? What is your goddamn... Mesh selector parameters? Is that what I'm... Mesh selector type. What is it called in here? It is called template descriptor. Oh, I need to cast selector. I need to do this. What is mesh selector parameters? What class is this in? I need to do this. Yeah, what is mesh selector? This is in U environment item spawner. Is that yeah, so settings, mesh selector parameters. There we go. Okay, so selector. Now we have template. There we go. Now we have it. Okay, so now I can check navigation, force navigation obstacle. So if this is false, and we also, I need to get the terrain chunk as well, because that's going to have whether or not the terrain chunk is rendered. Where's like original component and stuff? Context source component. I'm going to guess I can probably get it that way. Get owner. Terrain chunk. Cast a terrain chunk. Okay, so I have the terrain chunk. So if terrain chunk and terrain chunk be mesh rendered, if that's false, let's move a little bit of this. Actually, this is a messy condition. If there is no terrain chunk or it's rendered, do an early return, change it to an early return to fix some of the nasty nestedness. If there is no selector, which there shouldn't be, oh, I don't like this. I don't like this. Put it back. Too many conditions. Put it back. Put it back. Put it back. No, put that back. Put that back. Put that back. Put that back. Okay. Yeah, that's just, that's what this is going to look like. Okay, and so here's the condition, and now I don't even need to... So we're just going to... Context, no, in tag data. Do I just make the data null pointer? Because I don't want it to do anything with it. Or do I just make it, do I initialize it to an empty UPCG data? You know, that's not the way to do that. How does this usually get created? Do we do that in the prepare data internal parents function? We do that somewhere, right? Point data, output point data, new object, any thread with context. Okay, we'll do one of those. That seems to be the move. Output point data. So we'll just like override it with some empty dummy data. Settings, selector, rain chunk. Let's move some of these. Yeah, let's move these out. And just put it all in one. Selector and terrain chunk. Get rid of a little bit of the nesting here. Num inputs equals 0. Let's also do this up here. Just before everything. Selector and terrain chunk, and the terrain chunk is, that should be not rendered. And this is not a navigation obstacle. Then we reset the point data. Okay, so this is if the mesh is not rendered and these points do not affect the nav mesh, do not spawn them. I'll say reset point data so that we do not spawn them. Okay, let's see what happens there. I am quite interested to see. Will this work the first time or not? That is the question. I suppose I'll run to the bathroom. It's gonna take a little bit. BRB. Let's see if that works. Maybe that will solve a little bit of the hitching too, because there's not very many of those chunks actually rendered. Yeah, there's only a few. Still a little bit. Oh, I may need to fix up the metadata. Attribute static match is not in the metadata. Well, it properly didn't spawn the... Oh, that one. Okay, well that's for the graph that I'm not using the spawner on, so that's good. That's actually fine. That grass is fine. Now, I guess it didn't like that attribute static mesh is not in the metadata. So that, yeah, that's all of the errors here. Okay, attribute static mesh is not in the metadata. Yeah, so I guess maybe what I should do instead, just to get that error to go away, is the point data. I should just remove the points from the point data, not necessarily create a new point data altogether. Okay, so you can just do this. And I'll initialize it. I want that. And I want that and that. So copy those guys. There we go. And so we want, where is the intag data dot data? There we go. Pointer. Now, no, we don't want output, do we? We initialize it from point data. Output point data. I guess it's, we have a mutable version of it now, so set points to empty. There we go. Kind of an annoying way we have to do that, but let's see if that gets rid of the error. We're just removing all the points from that data set. I don't know what kind of like downstream implications that error is going to have, so I'd rather just it go away so I don't have to worry about it. If I can't see the error, it can't hurt me, right? Okay. So I should see trees over here, but no grass. The thing is, like, we're still tagging the data with all the RNG stuff, so the hitches are still going to be there, actually. Okay. Yeah, this seems to be working, question mark. Yeah, this is working. This is working. Now, I do want to make sure that the serialized data still looks okay here. So let me look at x equals 1, y equals 4. What are our logs here? Because I should have like the saved data side. And let me just search grass. Uh-oh, save 0 points. Okay, see, that's what I was worried about. So we didn't save the points. So what's the point? Let me check another one just to make sure. X equals 1, y equals 3. Let's check that one. Yeah, still saving 0 points. But I saved 8 megabytes. No, I didn't. That's like that's a super small number. Okay, so I shouldn't. Oh yeah, because I never put the data back. So I need to do this. B result. That actually makes sense. Return B result. Let's just, we're just gonna return that there, so we don't have to worry about that. Okay, so let's also, we need to save the points here somewhere. So we need to get points. Array FPCG point. Points. And that is returning a copy. I guess I can I return a ref here and then set points. Yeah, because I guess that will copy it when I do the set, right? Get mutable points equals the ref. Okay, that's a little worrying. I want to copy here. We're going to copy the points. It's going to be kind of expensive, but at least we know our points will be valid. So valid. Maybe I'll copy. Let's copy it from this point data. Actually, I like that better. Because that point data is the input point data. Call this saved points. Don't pass point data to prepare data internal so that we do not spawn them. Add them back afterwards so that we still serialize them. Do I spell afterwards wrong? Add them back afterwards. Add them back afterwards. You just, is afterwards not something that can be plural? Okay, let's see how that works. Okay. I'll keep that log there just so we can watch that one chunk that we know should have some grass on it. We'll see if that grass pops up properly now. Oh no. What is this? Uh-oh. Uh-oh. This is a breakpoint I think I put in here a long time ago, and I don't, I guess I never removed it, and now I'm hitting something that is a boo-boo. And that is invalid metadata key. Check for entry key not properly initialized. Why don't I just do this? Afterwards, I'll do intag data equals the point data. Maybe we should try that instead. I don't know what the ramifications are of that, but it's a warning telling me some metadata isn't initialized. There's definitely something to do with what I just did there. Uh-oh. Uh-oh. This wasn't happening before. Metadata is not valid on this point data. The point data isn't even valid. Current output point data. Points is empty, as it should be. Current point data is none. Okay, context current point data is none. Current output point data. That's not supposed to be the case. I'm not editing the context at all. Context is still the same. Other than the input tagged data, which is now... Because that's a const pointer, correct? It is. So I can't, I can only set that. I can't, like, edit it. And I do exactly what it does internally to initialize this data. New object, any thread. Is this just becoming invalid? Is it just becoming invalid? And endpoint data 1, 2, 3. It's the third argument. So it is this current point data. Okay, where do you get set? Literally right above here. So okay, what's the condition if B current input setup is false? Was it? No, it wasn't. It was true. Oh boy, now I get to go find out why that's the case. Oh boy. And that is context current point data. Should I just set that manually? While current input index is less than inputs num, there's only one. Context B current setup. Context B current setup or whatever. Where is that at? Current input setup. It is true. Okay, let's go find out. Go find out why and where that gets set. Okay, it literally only gets set to true, or it gets set to false when we reset it. It only gets set to true if it's already been set. Okay. Okay, do we have another instance of garbage collected pointers? I don't understand why. Let me look here. Output point data. What are your flags? What's your freight? No flags. So we're not marked for garbage collection there. Current point data blah, 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 blah. Dude, should I just like, instead of doing all this, I just like return true, right? Am I overthinking this? What should this return? I forget what this should return. This returns probably true when it's like done or something. Or if it's executing. False when it's done executing. So can I just return false here? Is that all it takes? Don't prepare the data. Don't do it. And I wrote a comment about this, right? It could take multiple frames to complete if prepared data returns false. So wait, I should be returning true then. Okay, I think I might have done that backwards. Yeah, because I returned true up there. Okay, okay, go back. Turn true. Okay. Will she work? Yeah, do it. Do it now. What now? Okay, I see no warnings or errors in the logs. Will this pop up with no grass? It did. Yay, no breakpoints either. Good, Anakin, good. Good. Still very hitchy. Very, very hitchy. A lot of saving is happening. I can see it. I guess we're loading a lot of points too here. Loaded. Let me just look at grass. I need to go touch grass. Loaded 0 points. Oh, I do see some saves happening. Yeah, I guess we have it set to load. And I'm wondering if a lot of these already saved. Well, no, I have it set to, I don't have it set to load, do I? Why would it be loading? You shouldn't be loading at all. You should be set to overwrite data. And you are. So why are we loading, actually? Question mark? We are saving points now, though. That's good. That's good. What about loaded grass? Or loaded anything, really? Why are we loading? I should have commented this better. Famous last words. Okay, so I think maybe the why it's loading is like it should be loading from cache, right? Like I should be saving these things, and then the node will load them from the cache. But I guess that doesn't explain why UPCG container loaded here. Because this is doing the deserialization, which I don't think should happen. I don't think that should be happening. Go track this down. Well, I guess undo those. Because this function does get called to load from cache. I want to know if we get here. That's what I want to know. That's what I want to know. And also, no, let's run it again. I was gonna say let's delete all the save data to just get a fresh slate, but then that's not gonna test it. Then is it? Okay, we are loading. It has triggered a save. It is Yeah, so that's why. Save exists. Did we like reject this from the cache already? Are we clearing things from cache? Give it unload. Yeah. Does this ever get hit? Is my next question. That would mean it's not in the... If it's not currently loading and the hard refs does not have it. Wait, what am I doing here? If currently loading slots doesn't contain it. Okay, so if we're not currently loading, or we are currently saving, we load it? Wait, why would I do that if it's currently saving? That's probably why. Oh no, currently saving has nothing in it here. Okay. So yeah, why isn't this in the either currently loading slots? Ground mushroom terrain chunk 2-2. Ground mushroom terrain chunk 2-2. Wait a second. Currently loading. Oh, I just added it. That's why. That's why. Okay, yeah, I guess I'm a little worried. Yeah, save and unload PCG save. Where is this all? Yeah, there's only a couple of places where that gets called from. Either serialization, which I suppose that never gets hit at the moment. Yeah, so I want to know when that's happening. If that's ever happening. And if not, okay, I feel like the save container hard refs, I add that when I load it for the first time. And where else do I put it in the hard refs? I hope when I save it, because I should only be saving these. Save container hard refs, let's do a find for dot add. Yeah, I mean, I add it immediately when it's saving. And nothing has gotten unloaded from the cache. I will... So there's some weirdness happening here. Potentially some unnecessary things. This is exactly why I didn't want to dig into this, because I knew I would be getting into this very obnoxious save system that I wrote. I have no one to blame but myself, really. Quite simple, really. Currently loading slots. Yeah, anytime I load, right? And this is the only place the save container load was happening from. It's the only way it can get loaded. I put it in save container hard refs. When else do I remove it from here? Only there, and that never got hit. I mean, let's run it again just to make sure, make absolutely sure that that breakpoint's never getting hit. That is indeed the case. And I guess let's double check each of these nodes to make sure They're all set to override data. That one was, I checked that earlier. Overwrite data. Yes. Overwrite data, yes. Overwrite data, yes. Where did you just go to? Overwrite data, yeah. So they're all set to overwrite data. So they should all be saving. Now I get to figure that out. Could there be some sort of raise condition here? I feel like it's got to be something like that. Yeah, load PCG save should be getting called. We shouldn't ever be reaching this point, and we are routinely. I wonder. I wonder if we hit a little bit. So if it is in the save container hardware, which it always should be down here. Yeah, if it's already come through here, it should already have been added into the hard refs. That's the first thing that happens here. And if it got removed from currently loading slots, that would have had to have happened in between these two lines. Let's put a breakpoint there. That's... Well, no, we'll hit there plenty of times, but it should be... Let me see, actually. Let me see that. Is it because it's contained in currently saving? Which is weird that Why would I have done that? I don't know why I made this rule. No, currently saving is fucking empty, so... Save slot name, stuff around trees for terrain chunk 2-2. And B has triggered save, gets set to true. When I serialized tagged data. If it's not loading, which is false. Okay, so that's always false. And the tag data is not empty. Oh, is that the issue that's happening now? But wait, I don't change the tag data. Or just is there none now because the prepared data never got called? And prepared data is what sets the output data. So else if is loading. I mean, nothing should be happening in here actually. And then I guess like save and cache PCG save would never have gotten hit. But has triggered save is set to true. Which means we get here. Okay, so I think the output data is a problem. I think I need to... I feel like I should just pass the input data through as the output data. But isn't that what I was doing? Here, go back. How were they updating the output data? Outputs, tag data. Outputs, add ref. Okay. So am I gonna have to manually do I need to do this every time or just only if there isn't an output? I want that. I want that. Come on, writer. All I did was copy. And what was input supposed to be here? What is this? Current input index, inputs. Okay, it's just the in tag data. Okay. I think I didn't delete that, right? Yeah. No? Oh, because it's a pointer. Yeah. Okay, so here's my output. I mean, I just added to the outputs. And theoretically, that's a copy. But what else? I forget. What else did they do to the output here? Outputs. Output dot data equals output point data. Okay, maybe I need to do that too. Okay. Maybe that fixes the issue. What's the deal? Oh yeah. Oh yeah. Yeah, oh god. This is just so tightly coupled and integrated. Okay, now I don't feel like I can do this. Oh, I should be doing this a different way. Okay, so the prepared data internal that I'm trying to like bypass right now, it like packages all like this mesh instances data, which is like all the data that eventually gets turned into the instance static mesh and what gets spawned into it. And so I'm trying to like save shit. I mean, this is my own code, so I can just like easily change this. Yeah, maybe I can still do this. This is just feeling like I shouldn't. So I'm going to be saving no points, right? Or rather, I'm going to be saving points that don't have any of this mesh instance data. Okay, maybe let's just bypass this and see what happens. Oh god, where the hell was that? There we go. Maybe I can still do it. Return here. But I'm not gonna be saving 0 points. I'm still gonna be saving points. They're just not gonna have this mesh instance data, which that worries me because I feel like I rely on that in a lot of places. Oh god, get all these out of here. I have so many of these open. Okay. So let's run it again. Do I still have that breakpoint in the subsystem? Yeah, so we'll see if that happens now. So we don't want that to happen. Okay, nothing yet. Nothing yet. Okay, that's good. So the word loaded should not be popping up here at all, right? But we're just loading from cache, which is what we want. We only want to load from cache. Let's pick a chunk here. X equals 1, Y equals 3. Okay, each thing only got loaded once. That's good to see. No unnecessary things happening there, it seems. $13,000 grass points, 1.5 megs. 7 milliseconds. Okay, I think that's happening how I want it to. That's the saving flow. That's the saving flow. So let's check out the loading flow and see what happens. Not you. Okay. So now we are set to not overwrite data. See what happens. Should be much less hitchy. Yeah, that should be getting hit. Because we're no longer going to be running the RNG anymore. Yeah, that loaded quite a bit faster. Wait, are we done already? Yeah, that loads. That's so much better. That was so much faster. No hitching. Yeah, we got rid of it. Well, it's just I mean, it's still there. It's still going to happen when we're running the RNG for the first time. But when we load from disk, we don't need to rerun the RNG because we've already determined what all the points should be. So we skip that. And yeah, everything got loaded a lot faster. And when I turn back on like the chunk serialization as well, and it's just going to be a lot faster. And then this graph isn't even doing the serialization stuff, so this graph was getting generated every time. But this one over here. This one over here is what we're testing with. So yeah, we're looking good. Let's I want to make sure that the word saving doesn't show up here. I guess saved, because the word save is in every one of these, right? Yeah. Because of save container. Okay, so the system wasn't as broken as I thought it was going to be. Seems to still work quite fine. Quite fine. Can I see the cache size? How much data do we have cached right now? 51 megabytes in our own cache. Not bad. Not bad. Is it not bad? I guess we're keeping the grass, which is like that's the majority of it, right? Yeah, there's several megabytes of grass. How much is the trees data though? Very little, very little. Isn't there unused data that you could filter out? Well, this is just for my LRU cache, which it's designed such that LRU is least recently used, in case you don't know, which means that it's effectively how I'm going to keep some of these save files, these binary save files, in memory when they're being used a lot, like when they're in a hotspot for colonists or something like that. And it'll, as that fills up, once it gets past a certain limit, it will save the ones that are least recently used. And so that's kind of handling the filtering out the data for me. But I may not need like some of the grass data to remain around. Like I may not want to have that, and that's what I'll be doing That's what I can do. Next? Did I do that next? Well, the answer is yes. Well, the answer is I'm already doing that, sort of, but I can take it further. I'm doing that a little bit. We can go further. But I mean, 51 megabytes isn't bad. I mean, we're keeping grass in memory when we don't fucking need to, so... The only things we need to keep in memory are like the interactables. So that's like, I was mentioning earlier, there's really just like 3 types of points, 3 classifications. One is, and the most important are things with collision, because that affects the nav mesh. We got to keep those in memory so that the nav mesh can be built around them, like that. And so when a colonist comes over here and chops down a tree, we remove that tree and it'll rebuild the nav mesh, you know? And then the second classification of points are points that don't have collision but are interactable. And these are things like the mushrooms. Right there. And those are properly underground. They're properly not rendered for these ones. So they're not actually spawned in instant static meshes. And then the third classification of points are points that are neither affecting the nav mesh or interactable, which is right now just grass. And also what happens to be most of the points, because it's foliage, you know. So what I could do there, well, I should probably run around a little bit and make sure everything renders and stuff as I walk around. Let's try that out, see what happens. Okay, we are loading. I guess I don't know, because I'm just running the graph again, and the graph has its own cache. I feel like I'm going to have that same issue that let's run this way. So no stasis distance actors will continue acting after you leave the area. Yes, but they won't be actors. That's what my ECS system is for. And that's why I have the nav mesh rendered way out. What the hell is that? Okay, ignore that. Okay, see, this is what I'm worried about. Yeah, I think it's just... I think it's caching this. I mean, we are still running the load. Let me... What chunk is this? 03? We just saved some data. Why? But yeah, the goal of the game is to have things acting from as far away as possible. I'm hoping to do the entire world so that the colony simulation keeps going. But that's what the ECS system is for, and I have like vertex animated instant static mesh. You know, humanoids that'll be used for colonists in the distance, and then they're just kind of, you know, little bits of data moving around in memory when they're not even in view. So that's what I'm doing all this for, essentially. Okay, I guess I don't know what happened to this node with this chunk. Let me see if this thing got reached over here. Okay, I'm gonna have to do like a specific log here. This is 03 0, 2. Okay, so if drain chunk board equals, what did I say, 0, 4, I want to know that can fit. 0, 2, yeah, 0, 4, 0. Yeah, that's gonna fail. Okay, that's very good. Okay. Well, I'm going to keep running. That's a bad spot. Can't run that way. Did it render? It did. Okay, and it did not hit that part. Oh, it's spawning things on top of this too. Oh yeah, because I'm not calling the... Yeah, I get why that is. Okay, so that should have... Yeah, what's the load flow? Let me go back over this. I think maybe because I saved the output data like this, it doesn't have the proper, like, tagged stuff. So it should have reached this, where we load the save. If we should save... And so that this is where we... Does save game exist? And... Wait, am I loading twice here? What's happening? Okay, we're putting the input data back in. Okay. We do this. I verified that this did not get reached. So we do prepare data internal there, which... I mean, theoretically, should have like tagged all our data and everything and spawned it. Data to ISMCs. Okay, so why isn't that stuff popping back up? Let's run back. Run back this way. Wait, do I have that breakpoint still there? Yeah, I do. Okay, yeah, run back. I should probably change all the logs in that file to use terrain chunk as well. That had to have unrendered by now. Yeah, it did. Okay. So let's follow that execution. Where do I want to put this? I don't have terrain chunk there. Okay, we'll just do this. No, I almost did what I didn't want to do, and that was stop the game. Okay, so I should be hitting this breakpoint. Okay, we still didn't render it. Did that render it? No? It still didn't render? Or we just never hit the right thing. It did render. What the frickin' frack, man? Okay, so this somehow isn't getting hit. We run that unconditionally, right? The only time we return before that would be here when we're loading or saving. Or there is no save name. None of those should be the case. So we should be getting here. Unless inputs num equals 0? Does this get hit? Zero 4 0. That is the chunk that I want, right? Yeah, 0 4 0. Sure enough. Bro, what? What is happening? Is it never running PCG again? Like the graph is just never, it's like completely cached? Run PCG. Where are you called from? Yeah, you're called both when physics is completed and okay, yeah, I guess I didn't see any where's update terrain chunk? Let's change this. Update terrain chunk. Changed to not in view. Changed to unrendered. And then no, this one should be there. Okay, so now I know that at least that stuff should be getting hit. Wondering if the on-crate physics state is not getting hit, which causes the PCG to run. I guess maybe let's do a log on that. running PCG. We should. Let's run back into view distance. Okay, it's in view distance and I saw no logs. Oh no, there we go. Run PCG happened. Okay, run PCG happened. Let's also, yeah, I need to change some of these logs to include the terrain chunk now that we're doing like a chord. Now that we're basing these graphs off of that. I just need more information. Prepare data internal. We always want to log the save slot name and the terrain chunk coordinates. I don't know that I care about seeing that anymore. Put this here. Handle prepare data internal. Handle prepare data internal. Put that stuff back in there. Coordinate toString. I'll say skipping, spawning, points. Do I have the save name here? I guess I have this save name. Yeah. Okay, so we have some more information now as to which terrain chunks are actually getting this node ran. So my fear is that the PCG graph just as a whole is getting cached, and when I regenerate the graph when it's already been generated, it just like never actually hits my code. Okay, PCG ran. Changed to unrendered, but none of my prepared data internal logs got hit. Okay, let's make absolutely sure that it's not getting hit. I will put one at the very beginning. And if this is the case, I really don't want to mess with the PCG cache. Like, I may as well do what I was saying before, where I'm just gonna essentially use PCG as a way to just generate the points, and then I'll just spawn them myself. Really. Because it's just, I'm gonna end up recreating it anyway. Render? We didn't move enough. We gotta run even farther away. Okay, we're back. Okay, it should have changed to rendered. It never did. Okay, we're gonna run around the corner. We're gonna run over there. We're gonna run directly on top of it. So the issue we're having here is like we've serialized some of these grass points. Uh-oh. Oh, I didn't Oh, I didn't get rid of the other thing. Can I please recover from this? Like, that's a pretty stupid thing to, like, crash on. Are you serious? Okay, come on. I'll live coding. Just let me... Okay. Maybe this can save it. I don't want to have to rebuild. Just because I put an extra param in a log and didn't actually provide the param. Well, if you're going to take this long to live coding, I guess I'll just rebuild. Thanks. My own fault. No one to blame but myself. But yeah, the problem we were having there is that we're serializing all these PCG points so that we can save on memory and not actually have them like rendered in the world. Or because we want to like simulate our full colony in the entire world, even when the player's not around. And we have procedural terrain, so a lot of challenges there. And we're serializing all these points so we can save on memory. And we're doing things like not spawning the grass. We're not even adding them to an instance static mesh component, which is what usually happens when you spawn things in PCG. Just to save on memory, because the grass, it doesn't affect the nav mesh. We're only going to keep things in memory that affect the nav mesh to a certain extent. You see, we've ended here. So here's all the things that, like, these chunks aren't actually rendered. There's no mesh here at all. There's no collision data or anything, but we're still spawning trees because the trees are affecting the nav mesh, and that is exporting the collision data, which we're watching build right there. And so we'll see collision data pop up over here, or not collision data, nav data, navigation data. What? Oh, save container is null. Okay, trying again. And when we've skipped spawning the grass and the things that don't affect the nav mesh, so we do want the graph to rerun when we run into view, such that the chunk renders. We want that grass to actually get spawned that time. And I guess what we're finding out now is that PCG, I mean, I've known for a while that PCG just aggressively caches everything. And so it doesn't seem like my graph is actually getting ran again when I do a generate, even though I have the cache set to 0 megabytes. So I don't know if this is just like an in-editor behavior or not, but even if it is, I don't really want to rely on it because I don't want... I tend to not like behavior that is different in development than it is in production. And I don't want to have to fiddle around with the internals of PCG to figure out why it's caching and tell it to invalidate the cache and whatnot. You know, I might as well just handle all the spawning and stuff myself. So yeah. We're trying to get grass spawned for the chunks over here, to read it from disk and load it, and actually rerun the goddamn graph. Okay, so we are close enough for it to have. Did it spawn that time? No, it didn't. Well, it's not rendered, still. Still not rendered. Okay, we gotta run around the corner. Unless I can get up here somehow. I don't think so. We gotta run around. There is a break in the mountains up ahead. Up yonder. Oh, I just saw it. It said skipping spawning points grass. Was the last thing that happened, which it's not rendered, so I think that makes sense right now. A cheat for flying. Yeah, but then I'd have to implement flying. Like, how do I implement flying? You got a code snippet for that? Okay, is 040 rendered yet? No, that would be this chunk over here. We gotta run a little bit longer. And I think it's valuable to still run around like this to get a feel for the game and how things spawn in. Okay, so yeah, run PCG got hit 3 times there. Wait, why did I get hit 3 times? First of all, I guess on create physics state gets hit 3 times. Seems weird. That would be the only way, right? Or if it unrendered. So yeah, physics state got called 3 times on create physics state. So we're spawning some new chunks here, so it's doing that RNG pitching. 040, yeah. So we didn't get that anyway. So okay, new plan. New plan. The new plan is to no longer run. We only run the PCG graph when it builds for the first time. All the points will be serialized. All the points will be tagged with their with the RNG to pick what static mesh is spawned there and what environment item, data table row they represent. And we are going to essentially spawn them ourselves instead. And so I think that'll mean I need to do some work in my HISM, hierarchical instance static mesh. Because there won't be one created. So there will not be one created, so I will need to, I guess, create one in a similar fashion. The PCG does it. I mean, maybe I shouldn't. Maybe I should always spawn them myself. Rather than using the underlying function. Once again, I am pondering whether I should recreate Epic's inordinately complicated wheel. There's something much simpler. So that I can have more control and better understanding of it. And then that means I can also use it in this. I can use it twice. I can use it once in here when the graph runs for the first time and spawns everything, and another time for my terrain chunk for every time that it loads thereafter, I suppose. Yeah, I still want the... I'm thinking even maybe I don't even want the node to spawn it, but then I think about like iterating on the graph, you know, when I'm trying to design, you know, do design and spawn things, and then, you know, I still need the node to spawn things for that reason, so I can iterate on this graph. Yeah, I bet if I were to force regen, does it did anything happen? Well, I don't know if anything happened there. It's not even regenerating. Okay. Kind of a big change. Maybe I should just try to... It essentially would be a function from the terrain chunk class in place of this. And I should just check if there are save files for this chunk, for this chunk's points. And then I guess I'll spawn a HISM for each save file. Although... Okay, so what I was thinking, spawn a HISM for each save file, and then just give the HISM the save file name, and then let the HISM handle it from there. Load the points, spawn the points. Which sounds nice. It sounds nice and clean. I like thinking of that, and then I can reduce some of the bloat in this subsystem. Then I'm like, okay, how do I know which class to spawn? Because the node you can give it a different class here. So I guess I'll have to serialize that and load that when the game loads, when the save file, the game save file loads. I think it might. I don't know if I've done. Yeah, I haven't really done that yet. But I think that what that's going to be, PCG components by grid cell, PCG save cell, it's probably going to be in here. And this F string should probably rather be a little struct that has a save file name and a class to spawn. I mean, I could load the data first. Yeah, I mean, I already have the subsystem working such that I could load it and just wait for the response, you know? And so maybe just the terrain chunk handles the loading. And then potentially they're already loaded when the chunk switches from rendered to unrendered or vice versa. And then I'm just giving the save containers to the... I'm still just giving the save containers to the HISM. I guess I'll need to check if there already is a HISM or not. For the save containers. How would I do that? I would need to like save. I need to save on the terrain chunk which HISM goes to which save file. Because well, and then PCG attaches them automatically. So I like PCG creates them and attaches them automatically. God, okay, so maybe I do need to recreate the wheel so that I can have control over that process and I can save which save file goes to which component, which hierarchical instance static mesh component. And then that way, when the chunk needs to update from rendered to unrendered or vice versa. I have the component to save file mapping. I'm imagining a tmap. And well, it would be save file name to component, and if there is no component for a save file, that's when I would do that process. Because some of them would already be spawned. Okay. Well, I do have PCG finished, right? I have, yeah, handle PCG finished generating. So I guess after... I guess when this gets called, I can do like a, let's try this. T-array, U instance static mesh component. Yeah, I guess instance static mesh components, get components. U instance static mesh component, instance static mesh components, there we go. And those should be the only ISMs on the train chunk, right? Well, I guess for the building system, I may use ISMs for the building things, and I probably should. So would those ever be attached? I mean, we'll deal with that when we get there. We don't need to worry about that. Let's just assume for now that we have one ISM, or each ISM on here is a PCG ISM. So when PCG is done generating, well, no, I guess I'm treating this as my base, right? Everything should have this as a base. So we use this. Okay, so then we don't need to worry about that at all. Let's just call this PCG ISM Cs. Okay, and then each one of these should have the save slot name on it. Okay, good. Okay, it's coming together. We can throw a tmap in here somewhere. Let's throw it by the PCG component. Tmap, F string for the save slot name, the object pointer for the do I do weak pointer here, actually? Or shared pointer? I think a strong pointer is here, because I'm going to be managing the life cycle of it anyway. I think regular pointer is fine. Environment item spawner, ISMC base. Okay, and so this is PCG components. Well, PCG ISMCs. ISMC map. Okay, so we're going to... There we go. Okay, so now we have those. Okay, but the problem is I don't know all of the save slots for this thing. But I know that the node actually registers the save slots with the procedural terrain subsystem, so I should be okay. I should be iterating over this and matching them up. Okay. Okay, so I need that subsystem. Do I already have that in here? I don't think so. Do I use game state or game mode in here? No, I don't. Get rid of those refs. Don't need those anymore. Component world map, PCG component. Okay, let's get the T object pointer, of course. U procedural terrain subsystem. There we go. Let's get a reference to that. Where should we put that? Where should we put that? Top. Okay, so we have that. So when it's done, this should have all of the PCG save slot names. Find board, which I need to look at this. Hang on. I don't think I'm saving them correctly anymore. Grid cell. That's on serialize. We're ignoring that for now. Serialization is not going to work properly at the moment. We have an add there. Find or add here. Okay, grid cell. Add PCG saved cache. Grid cell. Grid cell. Load PCG save. PCG component grid cell location. Is that where this one comes from as well? New procedural get PCG grid cell. Okay, so I guess we're using the location. Okay, so let's change that. To one, let's just change the name. Rain chunk. Okay. We'll just leave the name that way. Okay, but now that should be saving it with the proper identification. Okay, so now I can get my T set of F string, which is my save slot names. And it's a pointer, sure. For each save slot in save slots. I guess we'll just kind of like initialize the map here with empty things, and then that way, if we get one that's empty, so run PCG. So here, instead of run PCG, because that's going to do nothing. I guess I need to know if it's already ran or not. I need to know if it's already ran or not. I wondered... I call run PCG, but does it, yeah, I guess it always would do handle PCG finish generating. Even though it doesn't actually generate, it just returns immediately or something. And so I guess there's two cases I need to handle here, maybe, then. One of them is, we'll do if the mesh rendered. If it's rendered, and there is an empty, and there is a, one of these not spawned, if entry.value continue. But if there is one that is not rendered, then we need to like we need to spawn it and do the rendering and shit. The procedural terrain subsystem, get or load PCG saves. Can I just load PCG save? And I can await on that, so maybe that's when I do a I can do the background thread here, save slot name, which would be entry.key forward true. Okay, so launch, put this into a background thread. Background normal, thank you. Okay. Put that into a background thread. We're going to await on that. Put this in there, capture that, and also entry, of course, And this is going to return a UPCG save container pointer, save container. Okay, and then what do I do with this? Save container has like some mesh descriptor or something on it, correct, I hope? Mesh instance list, environment item descriptors? Wait, oh no, do I not, I don't save the template descriptor, do I? Well, here's where this plan just goes down. Well, we have this. Do I save that? I don't think I saved that. Mesh instance lists. Let me look at this. Update mesh instance lists. What am I doing here? Populate save object with output data. That's when I'm saving it. But what about when I'm loading it? Instance list. Instances and instances indices and static mesh. Oh, okay. Okay. Okay, so I don't, unless as of right now, unless PCG spawns the component, I do not know which component class to use. Oh, now it reran. Look at that. Took its sweet time, didn't it? Okay, so ah boy. Okay, what are we doing here? What are we doing about this? Think. Background music link, please. Of course. I should have a bits and hits is what you're looking for. I should be giving them credit, but I'm too lazy. I'm using a different method right now. And actually, let me turn that on. Oh boy, hang on, I got this. I'm using a live stream for it now instead of like shuffling through a Spotify playlist because I didn't want to pay for Spotify. But they move the little they move the name around in the video. So I have to keep moving this, which you can see that it's a bit of a pain. So that's why I just have it turned off until I get that figured out. There we go. But they say you can use the music as long as you give them credit, and I haven't been doing that for the past 2 streams, so sorry bits and hits. Love your music, but I've been lazy. And so this is a song from, it's all like songs from like video games and stuff that are converted into lo-fi hits. So this is from Witcher, it seems. Okay, so yeah, and it doesn't even spawn. I'm kind of thinking there's a couple options here for this. Either we kind of go back on what we did here where we just like skip the spawning if there's no points, and try to do what we were doing when it wasn't working, where we were just setting points to empty, and then maybe it still spawns an ISM if it's empty. But it might not, it probably won't do that. It probably won't do that. Yeah, this is all adding up to me. Just rewrite it. Just rewrite it into your own thing. It'll be so much better and easier. I just need to iterate through the points, grab the static mesh attribute off of it, and pop those into the HISM template descriptor. Let me see here. Select instances. That doesn't actually do any spawning. It happens. Does it happen in the execute internal? I think it does. Spawn static mesh instances. Yeah, that sounds like what I want. I guess the thing I lose is that it spawns things, or rather, I should say not spawns, but it adds instances to the ISM across frames, which is nice, a nice built-in feature. No, it doesn't actually. No, it doesn't. I lied. I think the part that it does across frames is the different ISMs. Like it only adds 1 ISM per frame per node or something like that. But it looks like it adds all of the instances at once here. Unless this instance list is... Unless this instance list instances are sliced up. Oh, it does have pre-existing instance count, so yeah. Okay, they do have this nice get or create managed ISMC function that I could use to just spawn the component, and it looks like you can just kind of, if I have the descriptor, I can just pack that up into a little struct. Are you exported? Are you serious? Okay, this function is exported. Let me just try something real quick here. Is that going to be DLL error? Let me try this. I don't see it as exported, so I think this is going to be like a linker error thingamajigger. Well, at the beginning of the stream I was talking about a couple different problems we have that we were going to try and solve today. And one of them was determining whether the vertices or the points that we're generating from PCG, which are actually coming from our vertex and index buffers from the chunk data. I was talking about like creating some voxel data to tell whether or not it's like to give some information about each point, right? And I was thinking that was going to be more difficult. And so I did this instead. And I think I was wrong. Okay, so that built fine, actually. Okay, so we can use that. I thought it had to be exported with like the API thing in front of here. I guess not. Okay, that's cool. So we can easily spawn the PCG ISMC with the template descriptor without having to like manually wire every single property on there. Like I assume that they already do that, and so that's good. Okay, where do I want to go with this? Yeah, I just need to create my own spawner function. Yeah, I need to override the execute internal, I think. Yeah, it is doing some async stuff here. God, this just does so much. It makes me worried that I'm gonna try and reinvent this wheel and make an inferior wheel. I could just copy the entire function, but that's not really going to work for me when I'm calling this from outside of a PCG node. Whew. Yeah, and I wonder what's going to happen if I add all of the grass instances all in one frame. Is that going to be performant enough? Yeah, and this PCG managed resource is not... I don't think this is something I want to use. I imagine there's some extra memory overhead with this. So maybe I won't end up using that little function. Where does it actually, like... Oh, here we go. The descriptor. Potentially less efficient to put nanite meshes inside of hierarchical instance static meshes, so decay those to ISM in this case. Interesting, okay. I will need to keep that in mind, I suppose. Descriptor init component. God, there's so much on here, man. There it is. This is what I that's what I was expecting. Okay. Yeah, this is the manually mapping each property part. But I guess that's a function on the descriptor. So I just get to reuse that. And it just does a new object with instance static mesh component, and it uses the descriptor class. Okay. So I guess I need to be serializing the descriptor in its entirety. Right? I'm going to be the one doing the spawning of this stuff. And I'm kind of ejecting from the PCG graph after it's been ran once. I need to serialize the entire descriptor, don't I? Either that or maybe I don't, and then I just spawn every instance static mesh that I need, even if it doesn't have any points for it. Well, doesn't that still keep like the static mesh that's assigned to it, like in memory or something? Yeah, maybe there's still some potential performance implications with that, but what I was going to say is maybe I just serialize the instance static meshes themselves, and then that way I don't have to serialize the template descriptor for them. Because I'll just respawn them. Well, no, if I serialize them, I guess I would have to hope that the built-in serialize method handles everything for me. Does it? Super. This is just the regular instant static mesh component, serialized method. We're here. Yeah, per instance static mesh data. Pontificating PCG, you alliterating dog. You knew exactly what I was going after. You knew exactly what I was getting after there. I knew what I was doing. And I'd do it again, too. You know what we're pondering here, Odd? We're pondering and pontificating quite promptly upon whether or not we should recreate yet another Unreal Engine wheel. Because it turns out Unreal Engine wheels are quite complicated for what they do. And you don't have very good control over them. Like spawning PCG, hierarchical instance static meshes. What is this? Oh, I need to... I put a bunch of stuff in here that wasn't ready to go yet. Yeah. Get rid of all that. Rerun it. Yeah, so what we're working on now, I'll just kind of recap for everyone watching. Like, my game world is I'm trying to have a full colony simulation across the entire world, and I have procedural terrain, and I can't have the procedural terrain rendered and in memory at all times. So what that means is I'm going to have to basically do game dev on hard mode, so that my ECS system that I built to move all the colonists around in the world and stuff like that. So that has things to interact with. I need to do a bunch of like serialization. I need to do a bunch of optimization on memory sizes. I need to load and unload chunks, the meshes themselves. Why is this happening now? Oh, okay. Save slots is null. That's understandable. I wasn't ready. But we're changing these chunks from like we're building dynamic meshes, and then we're deleting the dynamic meshes when they go out of view, but we're maintaining the vertex and indices buffers in a format that we can just export as custom geometry for the nav mesh. So the nav mesh is always there, even though there's not necessarily collision or a mesh underneath it. And we're going to use that nav mesh to move our entities around, but there's also going to be stuff spawned on top of the terrain, on top of where these chunks would be. And so we use that vertex and index buffer data to create our own PCG node right here, chunk surface sampler. And once I can actually get this running for real, I'll show you what that outputs. And that way we don't even need we don't need collision at all to spawn points at all. And you can see here there's no mesh here, but we're still spawning PCG points on it. This is good. This is what we want. We've written our own node here, environment item spawner. Not only does this work with data tables and have some regrowth settings, respawn settings on there, some extra RNG settings for how much should spawn and when, and some thresholding and stuff, but it's also serializing these points. So that actually didn't run the full graph. It loaded all these points because they've already been saved and serialized. And what I'm trying to do now is you'll notice there's no grass spawned, but there is grass here. That's because we don't need the grass loaded and spawned because it's not actually affecting the nav mesh. These are affecting the nav mesh, and you can see that there. So that's why we need those spawned in. So you got to simulate what's happening in data only to avoid the massive overhead of using actors. Yeah, using actors, using collision, just trying every way we can to reduce our memory footprint. Which is why I'm trying to get rid of the grass. And I've gotten rid of the grass, but what ends up happening is I've gotten rid of the grass, and then when I run into view, it doesn't pop back in. Because I am just rerunning the graph, and PCG just like aggressively caches literally everything. And even though I've set the cache to be 0 megabytes, it's still not rerunning my graphs properly and respawning the grass. Because I kind of like within the code of my own node, spawner node here, I skip over spawning the grass when the chunk isn't rendered. But you see, now the chunk is rendered. And there's no grass here. If I were to go into here, I'll show you what our own node looks like here. It may take a while for the cache to do its thing and whatnot. But it'll show up with like what this surface sample actually gives me without actually needing any collision. Because I just iterate over the triangles in here. And this node has like a nice little, I built in this points per square meter. So I get the area of the triangles and kind of use that to determine how many points each triangle should have in it. And I do some RNG jittering on it to make them not look so bad. And then I have like a filter points by normals. And this will allow me to call some of the points. And so here, all these little, and because I put the, these little debug points on here, it actually reran it. And it actually did spawn the grass. But it's not happening at runtime, which is what I want. But yeah, I have all these little, let me click off here. I have all these little pointers, right? And I'm turning on the collision here, so you can kind of see the triangles. Hard to see, maybe, but there's all the triangles. And so we're just using that data. We're not actually doing a collision trace or anything like that. And then that gives us all these points on the surface of this mesh. And then I can use that nice little normal filter direction with a dot product threshold. I'm saying this, like, give me every point. -1, that if you have a dot product of -1, that means it's pointing directly away from this direction. And this direction is just straight up. And so this is just giving me everything. Now, if I change this to 0, this would be, 0 would be perpendicular. So that should call everything on the top here whenever that finishes running. And when I was first testing this, I didn't have the calling for the grass or anything on there, so I was getting just like these really big fuzzy tunnels, which was kind of silly. But one of the next things we'll do is we're gonna need to voxelize some data. There we go. So that called all the points that are on the ceiling essentially. And then I do some additional culling on the grass for a slope filter, so I can get I use the angle of those further down the PCG pipeline. But I'll need to start saving some voxel data, because all this data is generated from compute shaders, eventually ending up in a marching cubes algorithm. So I think that's where in my marching cubes compute shader is where I'm going to be building out some voxel data, so I can tell each of these points, you know, where it is in the world. Is it underground? Is it on the surface? What material is it on? You know, and like I do have terrain deformation, so when the player comes and deforms the terrain and I want to show, you know, dirt there, or I want to put something in the player's inventory based on what they dug up or something, then I will do that, and I'll have that data to do so. For now, we're just trying to work on the runtime generation part of PCG, and it's just been a bit of a slog. Because, yeah, it's not rerunning the graph when I want it to. And even if I were to get it to rerun the graph when I want it to, there's still some extra computation happening that doesn't necessarily need to happen. And in order for me to get rid of that, I will need to reinvent the wheel a little bit. So that's what this was. I have this like PCG serialization system and stuff. So essentially I'm only ever going to stupendous Sunday slog. You son of a bitch. But what was I saying? Yeah, I have this serialization system, so everything's going to be serialized, and I should only ever need to run the graph once. And then I have the data. I can just spawn it again on my own. I don't need to interact with PCG ever again after that part of the process. Because it turns out The internals of the PCG framework are, yeah, not very round and quite complicated. So yeah. We don't have save slots, just return. So yeah, I'm just, right now I'm thinking like, how am I gonna reuse, if at all, their spawning process? Because they do it, I'm pretty sure what happens is they end up slicing up the data so it doesn't spawn all in one frame. And so I'm going to kind of lose out on that, which sucks. Unless I, you know, copy a lot of this. But yeah, again, not very round. Not very round. I guess I can execute it on the GPU, which is kind of cool. But I kind of want to save that those resources for running my compute shaders. Yeah, spawn static mesh instances. I will essentially need to at the very least copy these two functions. Okay, let's just copy. Let's just copy pasta. So we have more control over this. I can actually determine which hierarchical instance static meshes to load things back into. Is that what we're doing? Is that what I should be doing right now? I don't think I have access to the PCG helpers. I don't think those are exported. Find user function. What is that doing? Post-process function names. Oof. Yeah, I do use that. Oof. Okay. Wait, hang on. Let's think about this a little harder, even though I have been. Yeah, like I was saying, I guess if I serialize the template descriptor, then I may not necessarily need to do that. So should I just do that? The reason I don't want to do that, that sounds easy. That sounds easy, but there's several things on there. Mesh instance list, there's the descriptor right there. The only thing I'm saving is the static. Does this have a serialized method on it? No, it does. A serialized from mismatch tag. What does that mean? What do you know here? Okay, does the parent have a serialized function? No, it does not. What about this? Nope. Nope. No, it does not. I'm like, look at all these properties that I would have to serialize. Like, that's why I'm hesitant to do that. Started doing some TypeScript node work for my server instance pool and matchmaking web service. I miss Writer and CPP. Do you really? As a seasoned TypeScript veteran as yourself, I figured you'd be glad to go back to that world. But you're using TypeScript for matchmaking, huh? Interesting. Is that your entire server in TypeScript, or just the matchmaking part? And server instance pool. Yeah, what do most game devs use on the back end? Probably still C++, right? Oh, I don't know. I don't know how I want to solve this problem. Every option seems not great. Oh, your stuff's in AWS. Yeah, I would be quite a bit rusty there too. I haven't worked in AWS or JavaScript in several years. Now, Dart and GCP, I'm your guy. Or Java. Dude, yeah, I don't like the options I have to skin this cat. The cat's not very happy with me. Yeah, I mean, I feel like serializing the ISMs is the easiest way. But like I was saying before, I would need those to be... I guess I wouldn't need them to be in memory at all times, but I would need them to all spawn at least once. And then if they don't have any points, kick them out back into the serialized data. And to spawn every single one, even if it doesn't have data, would require... That would require me to copy, all of the stuff here. And then I need to, like, I guess I can just manually call my own function. I'm already tightly coupling this node with a terrain chunk, so might as well just call that function directly instead of relying on that weakly coupled call function by name thing. Yeah, it feels bad. It feels not right. Like, I feel like a PCG node should not have a strong coupling dependent on its owning component being a certain type that exists outside the PCG system. But like, what other options do I have? Because I need to know when the chunk is rendered. I create an interface. I hate that. Create an interface for one thing. Some things are coupled. Dude, that's what I tell myself all the time. Like, you know, sometimes at work, you know, you'll get that that comment like, oh, we don't want to tightly couple these things. I'm like, some things just make sense to be together, you know? And I've worked in some code bases where there was literally an interface in between every single class, and oh my god, was it awful to work in. That was an awful code base to work in. The Twitter code base was an awful code base to work in. And there was another one where, like, they took smart and dumb components. It was a front-end code base. And they took smart and dumb components, and they used that for every single component. And that was awful to work in as well. You just have, like, a million tabs open. Because everything has a... Every component has two files now. It was React. And that was awful to work in. Like, I'm all for smart and dumb components, but only when it makes sense. Same with interfaces, only when it makes sense. Not overdo it. Like, I don't know, man. Excessive ceremony and principle, yeah. I also hate separation of concerns. Well, I get it and I use it, but like I hate that as an argument. Because I feel like that can be like it's just drawing imaginary lines in the sand. Like so many times on code reviews I've gotten like, oh well, this class shouldn't know about this thing. Like, okay, but I think it kind of should. You know, like, yeah, what are your concerns? Yeah, it's like, I mean, the overall concept, of course, is, just, things, when you create a class for something and an API for something, it should, the number of things that is concerned with, or essentially the number of things that it does or handles should be scoped in a way that makes sense, right? That's basically, that's the concept. Like, yeah, you don't, and like that argument here would be like, yeah, the concern of this PCG node should just be to spawn things and serialize them. It should not be concerned with what state the terrain chunk is in. Well, I need to spawn things in a different way if the chunk is in a different state. So here we are. Now we're arguing on a CL about clean code. I remember in front end a decade ago, they pushed back against separation of concerns and said people were actually just separating file types, and said people were actually just separating. Definitely open to interpretation. Yeah, because now, like, it went from, a different file for HTML, CSS, and JavaScript to now we're in React, which is JSX and puts HTML into your JavaScript, which a lot of people laud it for. Like, that's nice. And I work in Angular Dart now, so yeah, I don't like having the template in a different file every time. It's either in a string or it's in a different file, and it makes it feel like I'm using that code base that has smart and dumb components for every component. And the template syntax for Angular is just awful. Like, React is so nice because it's just JavaScript, right? That's all it is. It's got some hooks. You need to understand like 3 hooks in React. Rest of it's a function. Rest of it's a JavaScript object and a function, and it is so goddamn easy to get into. It's also really easy to hang yourself, but, that's up to you. You can do that yourself. Angular is very opinionated about things happen, but you can still hang yourself. Like, the dependency injection nightmare that is Angular. Oh boy. That's why I pushed for using, we re-implemented Redux in Angular. And that solved a lot of our dependency injection issues, because now we just kind of have like this global store, and it forces us to write pure functions for our logic rather than having a MVC architecture, which is like, we have 2 different code bases now. One of them's like the old MVC and one of them's Redux, and oh my god, it is so better to work in the Redux one, even though it's still Angular Dart. I had a JSX bindings to some in-house framework because sanity. What was it before? Just HTML? Or just some like different template syntax? Nested JS function calls. Hell yeah, brother. How many indentations? Like, what's the max flip indentations? That sounds awesome. Was it coupled with jQuery as well? We get some jQuery fun in there. at all those noodles. Look at that noodle. Pretty sure the lead engineer did it all for job security. Do you think people actually do things for job, like, do you think that actually happens? Because, I mean, people make that joke all the time, right? Like, you write something unnecessarily complicated and it's for job security. Like, I don't know if I've ever had anyone, I've never heard anyone admit that that's why they did it. I kind of feel like engineers like to over-engineer, and that's how things get too complicated. And it's not, I don't think people think about job security. I don't know, maybe there are some people out there like that. Never made sense why they didn't just pick React, the hiring pool alone. I mean, yeah, that's the big reason, right? Everyone uses React. There's a library for everything, which can be annoying, but I see it as largely a good thing. I do miss it. I think React with TypeScript is kind of the best world for the most part. If it's a small app, JavaScript, totally fine, but larger business app, TypeScript, and you're good to go. Like, that solves like 99% of everyone's problem. JavaScript and React. I'm not doing anything anymore. I'm hungry, and I don't want to start this next part, which is going to be copying a bunch of Unreal Engine source code and figuring out why it doesn't work. And I'm hungry. Did I mention that? I'm hungry. I need some food. So I think I'm going to say goodbye to y'all. Let's see who I can send you guys over to. I think that's it for me today. I didn't really get anything substantial done today, so that's a little upsetting. But I did yesterday, so that's good. Small wins. Finn's on. Send you guys over to Finn again. Finn again, begin again. Yeah, thanks everyone for hanging out with me. Odd, good to see you. Have a good weekend, everyone. I don't know, I don't have much to say. It was a weekend. Things were done. Thanks for joining me. And yeah, I'll see you guys some other time. Peace out.